I don't think I'm forgetting. So we should be good to go. Yeah, it looks like it's working. Nah, not first, you're second. At least you're second on my end. I don't have anything prepared, so if people don't start sending in screenshots, you know, we're just gonna sit here in, I guess, like, awkward silence. Or can I share my RAM timings? There are instructions on screen. You upload your screenshot to Imgur, and then you just and then into chat, you just drop the, like, end part of the Imgur link. Because YouTube doesn't allow links, and I can't do anything about that. I mean, you could try it. Well, no, don't use a different image host. I want this to be consistent. Didn't see the text on my phone. Wait, how do you expect this to work? By watching it on your phone. Like, you're not gonna see anything. No. First person to follow instructions. Let's see what they sent. Oh, right, I forgot that the logistics of this were an absolute nightmare last time, so we're back to that. Oh, but, yep, that works. Cool. So, we got our first timings in. I guess the instructions might be too big. You know, maybe I should just put them up over here or something. I don't know. And maybe I could also just move this over to the side a bit. So, what do we have here? A 5800X3D on an X570 Unify running generic BDI timings. Actually, these are not super generic. These are a bit, these are on the tighter side of generic. So 14, 8, 14, 14, 26, 40, 4, 4, 16. Yeah, so primaries, TRDs, TFOG good, WTRs. This is basically as low as they go. I think the lowest I've ever seen is like 2.6 for this kind of speed. TRFC at 260, which, yeah, like, basically, I mean, some kits out there can go lower than that, but I wouldn't, you know, stress out over, like, lowering TRFC by, like, 20 clock cycles, especially when that can lead to really annoying to catch instability, as in, like, it takes a long time to show up. TRD, like, read-to-read SCL, write-to-write SCL 2.2, which is, that's as low as those go. TCWL 12, yeah, I mean, yeah, for TCL 14 makes sense. RTP 8, that's about as low as that goes as well, and then everything. And we also have the dual rank timings correctly adjusted. So, yeah, good. So, and voltages, 1.5 volts, and then everything synchronized. Yeah, so really nothing to, like, SoC voltage is kind of on the higher side for these kind of settings, but, like, it's not going to hurt anything. So, yeah, that looks good. Next timings. Let me just check that. Okay. We have a Ryzen 7500F, not a CPU you see very often. And it's running 7800 on a B650 HDV. Yeah, well, B650M HDV. I think there might be a full-size HDV that's, like, way worse, probably because it's a 4-dimmer. Yeah, I think there's, like, a 4-dimmer HDV, which would be way worse. But anyway, so we've got 7800, 2133 FCLK. That's, like, weirdly low for a new AGSA. Like, especially when you're not, like, when you're running 2-to-1 mode, it's not like you're running massive SoC voltage, so I would have thought, like, you would be able to run 2166 or even 2200 FCLK without having to adjust anything, but I guess it's not impossible for that not to work. Anyway, 36, 46, 46, 36, so this is A die, isn't it? Yeah, this is 16 gig DIMM, so A die. TRC at 94. Yeah, so really, like, everything really fine-tuned. TRD's at 8832, which, yep, that's, like, optimal for 2-to-1 mode. WTR is 616. Yep, that makes sense. TWR maxed out. I mean, minimized, like, it doesn't go lower than that. TRFC at 507. The other two don't matter. 8. You could probably run your right to... Well, actually, I don't think the right... Like, this was in the last stream that I don't think the right-to-right SCL timing on AMD actually does much of anything in terms of performance. Or stability. Because you can regularly set it to 1 and it doesn't have any negative consequences. TCWL, you don't get to adjust that on AM5. RTP at 12, that's good. DWR 16, that's good. TWRRD at 2, that's good. And then the dual rank timings for this don't matter. Refresh interval completely maxed out. And I'm assuming you actually tuned your terminations and drive strengths, because these don't look like the auto settings for the HDV, if I remember correctly. Though it might have changed since the last BIOS that I used. And for voltages, 1.135 SoC, CLDO VDDP at 1.1. It's on the higher side of what I've seen working for 7800, but that really varies by motherboard. Like, some motherboards and CPUs like it really low, and some motherboards like it really high. ASRock tends to be on the higher end of CLDO VDDP settings. MEM VDD at 1.4, VDDQ 1.4, VDDIO at 1.35. Yep, that makes sense. And yeah, like, this is just a very solid 2-to-1 mode 7800 setup. So that's cool. Anyway, let me move on to the next timings. Wait. This is the same thing. Wait, what? Yeah, that's the same thing. Okay. I don't know how I copied that twice. We've got another 5800X3D coming up next. Apparently, this person has not discovered the screenshot functionality built into Windows. Or, you know, even into Zen timings itself. But anyway, this is still legible. So we've got a 5800X3D on a B550 Aorus Elite. And it's running dual rank DIMMs. So this is interesting, because this board is, like, from what I've seen, because I've not used it myself, but what I've seen, this board is kind of terrible. Though I guess when you're running, this is two 16 gig DIMMs, right? Yeah, two 16 gig DIMMs. So that would help. Because it's like a 4-layer PCB, so if you're running like 4x8, it would probably suck very badly. Anyway, so we're at 3733. Gear down mode's turned on. TCL 14, 8, 15, 14, 21. So really tight TRC and TRAS on the primaries. And then TRCD, I guess this is just one of the like weaker memory kits of VDI. That's like where you see a lot of variance, is like the TRCD requirement. Like, some kits need a lot more voltage to run low TRCD compared to other kits. Also, the TRCD WR being at 8, that's completely fine. That's like, it doesn't really change performance much, but there's no downsides to doing that. TRDS, like, it actually, like, for certain scenarios, it helps a little, very little. Anyway, TRDSNL at 4.4, TFall 16, so that's minimized. WTR's at 3.7, so yeah, that's generally as low as those go. TWR at 14, that's a bit on the higher side, but nothing really wrong with that. The TRFC is also on the higher side at 320, and, well, 2 and 4 don't do anything, so I'm going to assume that you didn't manually adjust those, because, yeah. They're weirdly round for what I'm assuming are auto settings. And then read-to-read SCL4, WR SCL4. I'm assuming you just didn't check if 2.2 works, because a lot of the time that will. TCWL at 10, so tighter on the TCWL for the TCL, and that's fine, like that'll regularly work. RTP at 8, that's pretty standard B-die things right there. RDWR at 10, WRD at 3, that's, yeah, typical. And then the dual rank timings are on auto, I think, because your SD is at 5 and SD is at 7. And didn't we earlier have like the very first one was like 4.6? It's been a while since I've worked with Ryzen, but I feel like 4.6 should work for these. Let me just pull that up. Yeah, that should work. Yeah, like you should be for dual rank B-die, you should be able to run 4.4 and 6.6. I mean, you know, the second number here doesn't matter because you're on, I'm assuming dual rank. Yeah, it looks like dual rank memory sticks. So the second number actually doesn't apply because that's for different DIMM, whereas SD is same DIMM. But yeah, so 5.7, like, you're losing out a bit of performance. What's kind of funny about this is with Ryzen, because of the dual rank timings, if you don't manually tune, like, if you have, like, a very tight single rank setup, and then you just add 2 more memory sticks to it, and you don't tune the dual rank timings, you actually end up losing performance, potentially, for certain workloads. So, yeah, like, you kind of need to, like, it's not a big adjustment, but you really should probably look into adjusting those. So, anyway, you know what? I'm just going to keep this around as a reference, because, yeah, this is, like, good. And I've lost track of what I've copied in last. So, what are we at? ULSO. Wait, that one's twice. Okay, we've got a Ryzen 7000 set up next. Wait, no, I'm using that one as a reference. We've got... Oh no, why is your monitor so big? And blurry for some reason. I think that's just Imgur compressing the image. Anyway, so 7800X3D on a Crosshair X670E Gene, and of course it's running DDR5 8000, because as far as I know, that board basically does DDR5 8000 on auto. I am surprised that you're not synchronizing the FCLK for this, because as far as I know, like, the only workload that benefits from desyncing the FCLK at 8000 is, like, Y-Cruncher. And everything else, especially if you're not desyncing to, like, 2200 or something, like, yeah, like, why wouldn't you just run it at 2000? Like, it's different if you're at, like, DDR5 7600 or 7800, where, like, your synchronized Infinity Fabric is, like, 1950 or, like, 1900, so pretty slow. But when you're at DDR5 8000, yeah, if the priority is memory latency, you actually do want to run, like, you probably want to run the FCLK at 2000. Not that, like, it's not going to make a massive difference, but it does tend to be faster for, especially, like, gaming applications, for 8000 to be running FCLK at the same speed as UCLK. Anyway, as for the timings, we've got 34, 45, 45, 40, so A-die again, 45 on TRAS, TRC 85, TRRDs at 6, 6, and 24. So apparently the TRRDs, when you're in 2-to-1 mode, setting them below 8 doesn't do anything. Not that it hurts anything, it just, like, gets, like, performance-wise, it just gets, like, auto-corrected to 8, basically. So nothing really wrong with that, but yeah, like, if 8, 8, 32 and 6, 6, 24 should basically perform the same. WTRs at 418. Yeah, that seems like these two, like, the WTRs do actually, like, can have some variance from kit to kit. So yeah, I would have expected WTRL at like 16, but we are at 8000, so maybe the 18 is necessary. TWR at 48. That's as low as that goes. TRFC at 500. Yep, that's fine. That's what you'd expect at this kind of speed. And then TRFC2 and same bank is set to 1 because they don't do anything. Read-to-read SCL and write-to-write SCL at 8.8, so all good there. TCWL 32, you don't get to change that. RTP at 8, that's fine. RDWR at 16 and WRD at 2. All good. And then all of the like other timings are at 1, but like these two, like SC is always at 1 anyway, and then the SD and DD timings do not apply to this setup because it's single rank memory. Yeah, 1.2 volts SoC. That's really high SoC voltage for DDR5 8000. Yeah, this is definitely on the higher end of voltages for DDR5 8000, because typically, like, you need high SoC voltage to run high UCLK, but when you're in 2-to-1 mode, your UCLK is, like, really low. So, yeah, I'm kind of surprised that you're running that much voltage there. Also, 8034, yeah, so you're running a lot of memory voltage for this. I'm assuming, like, 1.6 or something. Maybe more than that, like 1.65? Oh wait, no, just... Are these voltage readouts accurate? No, they're probably not. It's DDR5, so the voltage sensors are like horrendous. Well, one of them's reading out 1.5, 1.6, so that's about what I'd expect. Oh, we do have hardware info. 1 point... Oh, yeah, so it's just under... Wait. So around 1.6, we're going to go with that. That makes sense for 8000 CL34. And then VDDIO at 1.435, which is very high, but that's like Asus motherboard things. And yeah, so like in terms of... Oh, and refresh intervals maxed out, obviously. So yeah, and then we have 10-hour pass of Karhu and OCCT, and wasn't there another something? Oh, and also memtest. That's 600%. Yeah, so that looks good. It's not really like, yeah, I wouldn't change anything about that. I should come up with some kind of queue system for this. Then we have a 5600X up next. And that's just single rank, not B-die. Oh, Micron Rev E. So we've got 3800, 1610. Why? Like, what is this? Why is it not 8? Like, it's not like it makes a big difference, but why 10? Did you does 8 actually cause stability issues, or is this just like is this, because I've seen also people where they're like TRCD-WR is at like 2 ticks or 1 tick below TRCD, and it's like, do you just feel weird about setting it to 8? So this seems like a like toned down version of that, but okay. I mean, it doesn't matter that much, but like it still is like, so you lowered TRCD-WR, but you didn't just set it as low as it actually goes, which I am confused. But anyway, so TRCD-WR at 10, TRCD at like RD at 18, RTP at 18, TRS at 38. Yeah, so typical Micron things. TRC at 56. Yep, very typical Micron. TRD is at 4416. Nice. WTR is at 26. Nice. TWR very loose. But I'm not the best at tuning 8 gig E-die Micron. I've really struggled with that, so I'm not going to question that TWR value. Anyway, TRFC at 550, which is good, and RDRDSCL at 4, and WRWRSCL both at 4. That's fine. RTP at 6. Yeah, that's cool. TCWL at 16, that's a bit weird. I would have expected that to be a 14, but if it works, like, it's not going to make it... Like, it's a write timing, so, like, most write timings, it's not as important as the read version of the timing. And then we have RDWR at 8 and WRD at 2, and those are good. For voltages, we're looking at very low SoC voltage, which makes, like, 3800 shouldn't be that, like, we shouldn't require insane SoC voltages. CLDO VDDP, though, is, that's on the higher side of CLDO VDDP settings. VDDGs are also on the, like, higher end of things, but you are running 1900 FCLK. VDIMM at 1.45. Yeah, makes sense. Like, your primary timings, wait, this is... Oh, yeah, actually, like, 3800 with TRCD18, that is pretty tight for Micron. And yeah, the rest of this looks good. And this is on a MSI B550 Tomahawk. Gear down mode is turned on. Yeah. Okay, cool. RAM can do 4000, but limited by Infinity Fabric. Yeah, that's the typical Ryzen 5000 series experience. Anyway, next timings. Wait, what? Oh, we got another 5600, except with a very different set of memory. Got some absolutely slammed B-die. Oh, this is for benching. On a B550 Aorus Master, 4733. This is going to be, 1.9 volts. Man, these are good sticks. And this is actually like a real... so in my experience, this is a real problem that you run into when trying to do these kind of like 4800... Like, because this is like mainly an Intel thing, but you can kind of do it on AMD as well, or you can run like 4800 CL14 with B-die. But with Ryzen, you run into a major problem of the memory controller really doesn't like very, very, very high VDIMM voltages. So like I modified my B550 Vision to go over 1.95 volts on VDIMM, and it literally didn't achieve anything because at 1.9 volts I can run like 4800 CL15 with the memory sticks. But at 2 volts, that stops working because the memory controller gets upset about the voltage. So basically, if you want to run these like very high clock CL14 setups, you basically need memory sticks that can run those timings at very like relatively low voltages for the settings. Also, if you're wondering, this is not even remotely like usable in day-to-day use, because for the like once you're running B-die above like 1.75 volts, and this varies to some extent from memory kit to, like from B-die kit to B-die kit, but once you go past like 1.75 volts, you have to run max mem, so you have to like block Windows from accessing all of the memory. So for something like this, I would assume the max mem is set to like 3 gigs. Yeah, but still very impressive. Especially the primaries, man. 14, yeah, 13, 13, 13. Yeah, that's slammed. TRAS at 26, TRC 29. This is tighter TRC than what you see people running at like 1-to-1 mode a lot of the time. Mind you, if you're wondering, this is actually going to be faster than like your typical 3800 CL14 setup. In fact, these kind of single rank setups can be competitive with like dual rank running 4000 CL14 in my experience. Somewhat depends on the benchmark, but for something like Time Spy or Y-Cruncher, actually for Y-Cruncher this is going to be absolutely beast, assuming it doesn't crash. Time Spy is a lot easier to run. Geekbench 3 also likes this a lot, but yeah, likes this kind of setup a lot. So. And it's also like this kind of thing is not, you can't do this on most motherboards. Like the Gigabyte B550 Aorus Master, Vision, Pro, because those are all 6-layer daisy chains from Gigabyte. Those are all capable of this kind of thing. The newer revision X570 boards from Gigabyte, like the Master, I can't remember. There's a 6-layer X570 that isn't the Master. There's probably an X570 Pro that's on a 6-layer PCB. Not the Elite, that's a 4-layer, and that won't do this. Yeah, so this, I've never managed to actually get this kind of thing working on, say, 4-DIMM MSI motherboards or 4-DIMM Asus. So as far as 4-dimmers go, you're only really doing this on Gigabyte boards in my experience. And then for 1-DIMM per channel boards, this actually isn't that hard. Like on Asus ITX, you can do similar settings. MSI Unify X boards can do similar settings. Gigabyte ITX is actually kind of not great because the ITX board didn't get the attention that the ATX boards did in terms of design, development, as far as I can tell. But yeah, and then ASRock. Actually, if you're on a Steel Legend, you might be able to, the like B550 ASRock boards might be able to get kind of close. I don't think they're going to be able to do 4800 with BDI, but you might be able to do like 4666 CL14 or something. Anyway, so yeah, this is really like I'm happy to see this kind of thing. Anyway, so yeah, smashed primary timings, TRDs, T-falls minimized, WTRs kind of on the looser side, though at these kind of speeds that might actually be necessary. TW, what is that? Why 20, what? Is this like the, did you not finish this? This doesn't look finished. TRFC is a 240, so that's slammed. Our read to read SEL, write to write SEL. I am pretty certain you can run these at 4. DCWL, okay, fair enough. RTP could honestly go lower. Read to write and write to read, those are fine. And then the dual rank timings don't matter. But yeah, like honestly, like getting the funny thing is like these timings aren't finished in my opinion, but just getting this to work at all is already kind of a challenge. So this is cool. Like just having these primaries working whatsoever. So yeah, cool setup. Man. Okay, next set of timings. Yeah, that's what I get for eating right before a live stream. Anyway, 7600X on an X670E carbon Wi-Fi. That is an interesting choice of motherboard for a 7600X. I'm assuming you're like waiting for Ryzen 9000 or something. Cause yeah, that's a rather expensive board for not that expensive a CPU. Which usually doesn't make sense. Anyway, we're looking at 6200. Yeah, 6200. This is Hynix, right? Yeah, this is Hynix. But why is the TCL so loose? This is some kind of weird, like, low voltage Hynix setup. Anyway, so yeah, 6200, FCLK at 2166, MCLK at 3100. Yeah, that makes sense. SoC at 1.275. Yeah, so that's about in line with like my expectations for Ryzen memory controller quality. Okay, well, now I should be fine now. Anyway, so yeah, 36, 38, 38, 38, 30, 68. So that makes sense for the voltages that you're running. But why you're running these voltages, I do not understand. Because like raising the VDD a bit so that you can run lower TCL is like not gonna like massively impact memory temperatures. But then again, it's also not gonna drastically change performance, so I guess it doesn't really matter that much. TRD's at 4816, so I'm guessing MSI lets you actually set the T-fall below the register limit. I don't know how that works out in practice, but I'm assuming that just gets auto-corrected to 20 by the memory controller or something. And for the WTRs, we got 616, which, yep, that looks fine. TWR at 48. That's as low as that goes. TRFC at 480, which... Hynix MDI. Okay, yep, that makes sense. 4.4 for the SCLs, so that's good. TCWL at 34, which is just the auto value. RTP at 12, like you don't get to change that, so that's always going to be the auto value. As in, like it's going to be your TCL minus 2. RTP at 12, that's good. TRD, WR, and WRD at 16 and 2. And this is a single rank setup, so we don't have to worry about the dual rank timings, and refresh interval completely maxed out. So, yeah, this is like like, there's nothing really wrong with this. I'm just a bit confused as to why, like, why you went with 1.3 for all the voltages. But, like, yeah, this works. Yep, I don't see anything. Yeah, this is good. It's good. especially like that's the funny thing with the Hynix DDR5 is like basically none of the timings scale with voltage, right? So like if you compare this to some of the like high voltage setups, the only difference here is that like your primary timings are slightly looser. Like if you were running say 1.43 on VDD, and actually at 1.3 I think you could probably run TCL34. But anyway, if you were at 1.43, I would expect like CL32 or 30, and then TRC DWR and RD at 37, RTP at like 37 as well, probably. And then if you were at like 1.6 volts, you could probably run TCL 28, or actually 28 should work at like 1.5 something, and then 26 would work at like 1.6 VDD. But all of the other timings would actually not change, which is, yeah, just kind of weird. Well, it's not really that weird. That's actually quite common that like TCL is kind of the only timing that actually gets better as you keep increasing voltage. Anyway, oh, and we're starting to get some super chats. So, except that first one doesn't have any, doesn't actually have any timings. So let's skip to the next one because, whoop. Oh man, why are you like this, YouTube? I just want to copy a damn link. There we go. So, next set of timings, we've got another screen too big. I can't see anything. A Ryzen 5800X on a B550 Unify X. Did you scroll down? Oh, whoa. 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 I mean, it's not impossible to fake, but I think, like, you wouldn't do that. Because, yeah, that... And what I mean by that is, like, you could start, like, hardware info after running the stress test. So, you know, because we don't know when it started, but I'm going to assume that, it ran at the same time as at least one of these. Because yeah, Ryzen 5000, when you push the Infinity Fabric too high, won't necessarily crash. It'll just spit out a bunch of errors and like you'll lose a bunch of performance. But well, you won't really see that in IDA. Well, the read speed, actually no, you would see the read speed absolutely tanking. Thing is, I don't remember what like good read speeds for a Ryzen 5000 are, so give me a second. So we're at 4200. And this is a dual rank setup. Oh, but it is a single CCD CPU. So yeah, that looks correct. That looks, man, that's a crazy CPU. That is an absolutely insane CPU. Like it doesn't even matter what timings you're running. Like if that works at all, that is an insane CPU. Yeah, and this is on a B550 Unify X. Man, that is just like 20 like it's rare to see chips where like 2000 works properly, and this thing's doing 2100. Now, let's judge them timings, shall we? So this is a 4200 CL16. So yeah, the VDIM is quite high to get this to work. 16's kind of on the looser side. Is this like not that great memory? No, it's 3600 CL14. Speed bin. Oh, well, fair enough. And TRC DWR at 8, TRC DRD. Like, the thing is, like, I'm wondering... Like, let me just quickly run this through a calculator. Oh, wait, I already have a calculator open. Give me a second. There. You guys can't see that. But basically what I'm wondering is, like, how much tighter is this than like, 3800 CL14? Oh, no, I don't like it doing it that way. That's 262. Yeah, that voltage is really high for CL16. Because this is like, in terms of cast latency, this is like looser than 3800 CL14. Now, I don't know, maybe there's like some different requirements when you push the memory this high in terms of like the voltage requirements could be disproportionately higher relative to the timings. But like, I feel like this should work at 1.5 in terms of the timings. Like, it doesn't make sense to me that like, or not 1.5, like maybe not 1.5, like maybe 1.55. 1.58 just seems unnecessarily high, but it's not gonna hurt anything. So yeah, that's just like an observation rather than a criticism. So yeah, because I would have figured like at one point, like if you were at like 1.6, I would have expected like CL15 or something at 4200, but eh. And this is like almost 1.6, so it's like, what? Anyway. Yeah, so 16, 8, 17, 17. RP could probably be lower. TRAS 35, that's weirdly high. TRC at 52, that makes sense with the TRAS that you're running. Though, yeah, that is like really loose for BDI, for the TRC. Like, it shouldn't have to be that high. Anyway, TRD SNL at 4416. Then again, I don't have any CPUs that function at 4200 at all, so... Like, I can barely, like, my 5950X can barely run IDA at 4200. So, you know, I'm not speaking here, like, I'm not, like, I don't really have experience with a setup like this. So there might be things that, like, just don't show up at lower speeds that this, like, struggles with. Anyway, WTRs are good at 3 and 7. TWR minimized, TRFC 250, good. TR SCLs at 4.4, good. TCWL 14 makes sense. RTP8, cool. TRDWR 10 and WRD2, cool. And the dual rank timings are loose, but I am not sure if you could actually run them tighter at 4200, because again, this is like this doesn't work on most CPUs. This is crazy. And in terms of SoC voltage, so we're at 1.212. Does hardware info perhaps read different? No, 1.212, cool. CLDO VDDP at 0.9, so that's like on the low end of CLDO VDDP settings. Though for this kind of memory speed, that makes sense. Like, you shouldn't need like super insane VDDP voltage. VDDG CCD very low at 0.9, and VDDG IODI very high. And that probably goes a long way to getting that FCLK to work. Are you perhaps raising the PLL voltage, the 1.8 volt rail? I'm not even sure if MSI lets you do that, though, on their boards. No, we can't see. But yeah, this is cool. It's a crazy CPU. That is an absolutely insane CPU. Like, this working at all is just like, what? Anyway, so I'll just scroll back up, and I guess we're just going to go random, because thanks to that one super chat, I've completely lost track of where I was earlier in the chat. So yeah, I really, really need to make some kind of queue system for this. Or figure out some kind, not make a queue system, figure out a queue system for this. Why is this link not loading? Okay, well, we'll move on to a different one. I haven't seen this one before, so we'll pull this one in. So up next, we have a 5950X on a Strix X570-F with 64 gigs of memory, and this is Hynix CJR? Yeah, CJR. 3800 will not boot. Yeah, I am not surprised by that, especially with this motherboard. Also, does that board even have a postcode? No, it doesn't, because it's a Strix board, so it's like watered down or like homeopathic ROG. If you had a postcode, you could maybe have some idea of what's going wrong. Because when like sometimes going for 1900, you'll run into like sometimes there's like one postcode that is like, oh, this is an Infinity Fabric error, and then there's one other postcode which is like, okay, that's memory error. But without a postcode, yeah, good luck figuring out what's going on with that. And I've forgotten which one it is. I think it's like F7 or F9 that you get if like the Infinity Fabric is like very upset about something. Anyway, so Hynix CJR, and we're looking at 16, 19, 19 at 37, 33 with TRC DWR8, TRAS very low, TRC proportional, TRDs 4 and 6, 16, so all good. TWR 10, WTRs minimized. Yeah, so all of the the first set of timings, those all look good. TRFC at 536. That's good. SCL's at 44, good. Yeah, all good. Like I don't have any like fixes for first of all, I've never tested 64 gigs of CJR because I don't have dual rank CJR DIMMs. And secondly, the one Asus 4-dimmer that I used on AM5 was, in my opinion, awful. Literally worse than an ASRock B550 Steel Legend in terms of memory overclocking, and that was the B550 Strix E board. So, yeah, like, it could just be the board. But also, I wouldn't, the thing is, the difference in performance between 3733 and 3800 is minimal, so I wouldn't really worry about it. I wouldn't go and swap motherboards because, oh, my memory doesn't do 3800. And chances are, with 64 gigs of RAM, most boards won't do 3800 anyway, because this is just a ton of memory. And you do have all your dual rank and different DIMM timings set up. So, yeah, good timings. Honestly, I'm kind of surprised that even 3733 works. If you said that this doesn't even post at above 3600, I wouldn't be surprised. Then again, CJR I think is actually easier on the memory controller than BDI. That's the annoying thing with BDI is that it's really, really hard to run. Regardless of what timings you're running. BDI is just heavier on the memory controller. So a lot of the newer memory chips, which are not necessarily better in terms of performance, are at least easier to clock high, right? And then they still lose to VDI in terms of performance because VDI has such a massive timing advantage. Though with Ryzen, you do have the VDI at 3600 might actually be slower than CJR at 3733 because 1866 FCLK does help quite a bit. Yeah, so I don't really have any ideas for what you could do about this. I mean, you could maybe try messing with the drive strengths and terminations, but what specifically to adjust, I don't know. And to me, it already looks like you've maybe adjusted those already. So, I mean, this isn't that far from what I would expect the board to do on auto, but at the same time, it isn't exactly I'm pretty sure the drive strengths always default to just 24 for everything. Which this isn't. So, wait, did I miss a bunch of super chats again? Oh yeah, so we had the 2100 FCLK Unicorn 5800X. Wait, apparently you can post full links? What? So I didn't have to come up with such a convoluted set of instructions, really? Anyway, so up next we have a 7800X3D on a B650 Aorus Elite. There's too many pixels. Oh, and it's running 8000. Damn. How old is the board? Because the Aorus Elite actually has like 2 revisions. Actually, 3 revisions. Amazing gigabyte. And yeah, and the first revision is an 8-layer PCB. And the second revision is a 6-layer, but I think they might have actually like I'm not sure about this because I've not gotten a chance to test one of the 6-layer boards. But wait, this is still 8 layers apparently. Really? Because I could have sworn, or wait, no, maybe the marketing materials are just... Because I know for, like, yeah, I am like 99% certain that there's like a bunch of B650 gigabyte boards that at launch were on 8-layer PCBs and then they got revised to 6-layer. I can't see the layer count indicator. The picture's not big enough, but yeah. Like, the thing with gigabyte boards is you can check how many layers you have because they have a little, like, layer count indicator typically down in this corner. So yeah, I'm wondering how old this board is. It's a revision 1.2. Oh, V2 is the 6-layer. Okay. I mean, the Rev 1.2... I think the Rev 1.2 is just a different heatsink, though. I'm not sure, like, I don't know if they, like, changed the piece... Like, I know they did... Like, I know for a fact that they changed heatsinks with some, like, revision 1 to revision 2 board... Like, revision 1.2 boards. I don't know if there were any other changes. And anyway, let's look at these timings, and, I mean, this isn't really stress-tested that, like, in Y-Cruncher. Because my experience, like, this is really weird to me, but my experience with, like, gigabyte boards is, like, really easy to run Karhu, really easy to run HCI, really easy to run Test Mem5. Like, they'll run forever, and it'll never be an issue. But Y-Cruncher on the gigabyte boards is, like, quite difficult. Though, I mean, I've not really been able to run 8000, like, at all, I think. And then on ASRock, it's like the other way around, where like Y-Cruncher is super easy, and then the memory tests are ridiculously hard. But anyway, so yeah, 8000, 2200 FCLK, which, yeah, when you're running 1.15 SoC, that makes perfect sense. CLDO VDDP at 1.05, yeah, which is what I'd expect for a gigabyte board running this kind of speed. 24 gig DIMMs. 36, 48, 48, 46, 48, 94. So, yeah, this is roughly what I'd expect from the primary timings here. TRDs 8 and 12. The 24 gig ICs will regularly not do TRD. Like, they have a bit of a TRDL weakness compared to the 16 gig chips. WTRS at 6, WTRL at 24. I think this is looser than it needs to be. Then again, like, I probably, like, if this is working, I probably wouldn't mess with it. So I'd just be happy. It's like WTRL isn't completely minimized. I don't like. It's not like it's gonna get that much lower. TWR at 48, good. That's minimized. TRFC 644, cool. TRFC 2 420 and the same bank 69. Yeah, these two don't actually matter, so you can put memes in there. So anyway, SCL's A8, good for this kind of speed. Like that's just what you run at this kind of speed. And then RTP12, read to write, and WRD at 2. Yeah, well, 12, 16, and 2. Yeah, so that looks good. And refresh interval completely maxed out, of course. Probably pretty high on the memory voltage. Yeah, 1.52 VDD, 1.4 VDDQ, 1.4 VDDIO, and tuned nitro timing. So yeah, this is going to be really fast. That is surprising that works on. I am surprised that works on a Four-Dimmer. Wait, how new is that BIOS? Because, like, I'm now wondering, because, like, I've really struggled to do... Wait, what? FA2? Oh, yeah, because of the different revisions. That's old. Yeah, that's a pretty old BIOS. I'm pretty sure I've tried this AGSA on my Aorus Extreme. And, like, I was... Wait, what? 60, 48, 60. These aren't auto, I'm pretty sure. Like, you tuned these, I think. Though I do remember, because I do remember trying, like, a certain set of, like, terminations that was like, oh, it worked at 7800 for longer, but it still didn't ultimately work. And then I gave up because it was, like, taking hours and hours before it would error out, and it was just like, okay. Yeah, I think it, like, errored out after 16 hours or something stupid like that, and I was like, okay, I give up. This isn't worth it. Because if that's, like, the issue when you get into settings that, like, error out really late into the test, is you end up in this really dumb situation of, like, well, maybe if I make just one more adjustment, tomorrow I'll find out if that was the issue. And it's just like you can't iterate on anything when it takes that long to verify stability. Right? Yeah, but this is 8,000, which like I've not had 8,000 work like at all on the Aorus Extreme. I haven't tried my B650 Master though for these setups. Like, yeah. Anyway, like, good settings. I am like, this is impressive, especially for a four-dimmer. X670E Steel Legend. I mean, yeah, these aren't that different from auto. Like, I think auto would be like 40, 48, 60 or something, or I might be remembering them backwards. And the drive strengths actually look completely auto to me. It's like, if I'm not mistaken, it's like one of these was the one that I needed to tweak to get 7800 to run for like 16 hours. It wasn't like I had to change everything, it was just one of them. And then it ran for significantly longer at different voltages than what I was testing previously, but it still didn't pass. So... How high can Hynix ADI go? Higher than your CPU. Generally speaking, higher than your CPU. Okay, next super chat. Got another 7800X3D. And also running 8,000, but this time on a Gene, which makes life a lot easier. This makes way more sense. As far as I know, that board basically does 8,000 on auto, which makes sense because it's a one-dimmer. Yeah, so we've got 8,000, 2200 FCLK, 1.15 SoC. The funny thing is, at 8,000, even 1.15 SoC is often more than necessary. It's just that, like, I don't, like, personally... I don't really see a point in, like, trying to minimize the SoC voltage that much, because I don't think if you're running your SoC at, like, 1.1 or something, you're going to be able to run 2233 FCLK. Unless you get really lucky with your CPU. Anyway, let's go through these timings. So, yeah, 8,000. This is, like, a sensible voltage setup, is it? VDD's bugged out again, but I think it's bugged out to 1.45, isn't it? Something like that. Let's see. I'm going to assume it's bugged out to 1.45, because the thing is, when the voltage reading bugs out, it, like, loops around. So if you have, like, a really low bugged out voltage, it means you're at, like, the low end of the high voltage mode. So I'm going to assume that's, like, a little over 1.43 volts is what this is. Probably 1.45. especially looking at these timings, like this isn't super ridiculously tight on the primaries, which would, like, tight primaries at this kind of speed usually require insane VDD voltage. So this shouldn't. And this is Hynix A die, and we're looking at 36, 46, 46, 46. Yep, so pretty typical Hynix A die primary timings. TRS at 58, which is on the higher end of things, and TRC 104. But for this kind of speed, that might actually be necessary depending on the memory kit. TRD SNL at 8832. For TFall, that's good. WTR 618, good. TWR 48, good. TRFC at 495, cool. Refresh interval completely maxed out. And then 88 on the SCLs, RTP 12, 16. Yep, it's a very, dare I say, generic DDR5 8000 setup for an X670E Gene. Man, I wish I still had one of those boards. Actually, no, I wish Asus would, like, make more boards with that topology. It's so stupid how, like, you have, like, one... Yeah, like, for AM5, you basically have, like, one board that basically guarantees DDR5 8000 support, and it's, like... And it's not even in, like, full mass production anymore, as far as I know. And, like, for me specifically, the PCIe slot layout is seriously suboptimal. Like... Because it's an M.A.T.X. board. Like, your giant GPU covers up the one other PCIe slot on the entire thing. I've been kind of wondering, though, if, like, how the, like, ITX AM5 boards compare to boards like the Gene. I mean, the MSI ITX that I have seems to be absolutely horrendous, but, like, that's worse than the Four-Dimmers. But, yeah, I haven't tried the other ITX boards from, like, ASRock or Asus or Gigabyte. Like, I've especially been wondering about the Asus ITX board, because maybe, just maybe, it has some, like, Gene heritage. Probably doesn't, because it's way smaller, but one can dream. Or at least hope. So, yeah. And we've got another super chat. Wait, did I miss any again? You'd think... Okay, no, I didn't. Cool. You'd think YouTube would have, like, a freaking super chat queue system somehow, but, like, they don't. So, like, I have to manually scroll from super chat to super chat, which is just, like, amazing. I'm pretty sure this is literally what led to the creation of the merch messages on LTT. Wait, what? I am apparently extremely bad at copying links. Okay, got the timings. Oh, it's another Gene, but this time with a 7950X3D and not running DDR5 8000. This looks like a workstation build. Yep, we got 6400. Apparently there's a second part to that link. But the second part does not work for some reason. Yep, doesn't work. Well, whatever. I got the timings, and that's the only thing that really matters. 6400, so yeah, very, like, you know, 1.28 on the SoC, because to run one-to-one mode at that kind of speed, you usually need very high SoC voltage. The FCLK is suboptimal for this. Ideally, for 6400, you want to run 2133, but with this much SoC voltage, I guess there's a chance that 2133 isn't stable, so I'm assuming that's why you're not running it at 2133. And then we've got 24 gigabit Hynix memory chips. So you could run your TRP lower. It doesn't need to be at 38. Not that it's going to make a huge difference, but yeah, like you could probably run it at like 36 or 34. With actually, okay, maybe not 34 with the voltages you're running, because this is some very sensible memory voltage compared to some of the other timings that we've seen today. Though I guess with this being 96 gigs, and this looks to me like a workstation setup, I assume you actually want this to be stable, and not running insane memory voltages does help with making sure that the memory doesn't get too hot without having to resort to like pointing a fan directly at it or something. And also, like, yeah, like raising the VDD just to get your primary timings down a couple ticks is probably like not really worth the Well, it depends on your priorities, but it's not going to make that much of a difference. TRDs 8 and 10, yeah, pretty typical 24 gigabit Hynix things. TFAW at 28, which is a bit odd. Like, this is functionally the same as if you set it to 20 or 16 or something, because it's already lower than TRRDS, right? Like, TRRDS is 8 times 4 is 32. So I am confused as to why this isn't like 32. Why 28? That just seems like a really random number. Not that it's going to affect anything, right? Because if you set your TFAW to, like, if your TFAW is lower than your TRDs, it just doesn't do anything, which this is. But I'm pretty sure the board didn't do that on its own, so you must have punched that in, and I am confused as to why you would do that. WTRs at 824. This is unnecessarily loose. These could be tighter. Yeah, like this should, like 616 should be basically guaranteed to work. Even like 416 should almost certainly work. TWR at 48, that's minimized. Cool. TRFC at 600, cool. TRDs, I mean SCLs, this no. If you're this is bad, very bad. If you're in 1-to-1 mode, at 6400, these really should be working at 4.4. And yeah, like in 1-to-1 mode, like 4.4, but honestly, like at least like 5.5. Like I don't see why 8. Like what? This is like what you would use for like 2-to-1 mode pushing like DDR5 7600 or higher. Actually, I think at 7600 you could probably run them slightly tighter than this. At like 8000, this makes sense. RTP is fine. RDWR, WRD, those are fine. I'm pretty sure your same DIMM, different DIMM, these can go lower. And these don't. Yeah. Like, for whatever reason, the write-to-write operations for dual rank don't go as low as the read-to-read operations for dual rank. But yeah, like, you're losing, like, memory bandwidth, basically, on your, like, SCLs and your read-to-read, same DIMM, different DIMM timings. Also, if you're like, but like no, there's no reason for these to be 8.8. Like for comparison, your different group timing is 1, right? So like if your memory controller is going from like I want to read group A to read group B, there's there's a 0 tick delay. It should literally be instant. It should just be read, like no gap between the commands. And then for reading in the same group, you're going to be like, oh, I want to read group A, like bank whatever, and then read group A, the other bank. And there's going to be like a 8-cycle. Actually, I don't think it's an 8-cycle gap. It's going to be like a 7-cycle gap. Like, because the reason I say that is that the SC timings on AMD, like this is 1, but I am 99% certain that translates into a 0-cycle gap between the commands. So it's like a weird like counting thing where it's like, how do you count the spacing between the commands thing. And yeah, so like you're like it does, like I don't, like I know it looks aesthetically pleasing to just have 8s everywhere, but like that's not how this works. Okay, it should not be 8-8. This just doesn't make any sense. But other than that, I don't have anything to complain about. Though I do wonder, actually, because you're all running 6400, there's a chance that if you tighten up the back-to-back, like the back-to-back timings, it might not do 6400 stable anymore, and you'd have to drop to 6200. And I think there's a chance that 6200 with tight back-to-back is probably actually going to have more memory bandwidth than 6400 loose back-to-back timings. It might even just generally have more performance. So that might be worth testing. If like tightening these like makes 6400 not work, you might want to check that 6200 like tightened isn't like Yeah, like tight 6200 isn't faster than what I would consider kind of loose 6400. Anyway, next timings. Let's see if I can figure out how to paste this one. Well, that's not it. And that works. Cool. What is this? Why do people refuse to use standardized software? It's MSI Dragon Ball. It's like MemTweakit. If MemTweakit was bad. Actually, it is a bit better in that it shows you your round trip latency timings without having to go through a bunch of tabs, but I don't like having to like adjust to different software readouts. It's just like the timings are in different places. Very different places. And they're not labeled the same. Okay, what is this? Z690 DDR4? Yeah. Yeah, this is DDR4. Is it? Yeah. Yeah, it is. The primary timings are way too tight for DDR5. But what is it? BDI. And what speed are we at? 4,000. Okay, so 4,000, 14, 14, 16, 16, 30. That is a weirdly high TRAS for BDI. I wonder what kind of voltage you're running for this. Probably over 1.5 volts. This is going to be like 1.55 or 1.6 to get TCL at 16. You're on an MSI board, so you should be able to run the TRP lower than that. Like, there's no reason for, like, you could run 15 TRP. Like, if you're on a Gigabyte board, you can't set the TRP separate from TRCD because Gigabyte still hasn't figured out that Intel implemented a separate TRP register. Because for the longest time on, like, your late, on like, from Z170 all the way up to, like, up to 10th gen. So 6th gen to 10th gen, the TRCD timing also set the TRP timing. Because there was just one register that set both of them. With 11th gen, TRP got its own register. And Gigabyte never got the memo. So if you're on a Gigabyte board, you can't set TRP and TRCD to two different settings in the BIOS. At least not on the public, like, retail BIOSes. There's, I think, some extreme overclocking BIOSes, like, actually have the TRP register properly implemented, but the public BIOSes don't. Yeah, but MSI doesn't have that issue, so you could have probably lowered your TRP a bit. Not that it would massively change performance, but, like, you know, you're running CL14 at 4,000, so it seems to me you're pretty interested in minimizing the timings there. Anyway, TRFC at 300, sensible. TREFI maxed out, yep. So basically, like, you could probably fine-tune the TRFC more, but, like, your TREFI at 65,000, it just doesn't matter what the TRF... Like, it basically doesn't matter what the TRFC is at that point. TWR12, that's fine. WTR S at 4, WTRL at 9, TRD at and S and L at 4.4, cool. RTP at 6. Why is T-fault all the way at the bottom when it's, like, related to these two? RTP at 6 is actually on the tighter end of RTP values for BDI. Like, it can work. That's not a problem, but you don't usually see people setting that for daily setups. T-fault 16, cool. And then is this dual rank? Is it single rank? I don't know. 7477. Yeah, this looks good. Yeah, the tertiary timings or back-to-back timings, those look fine. That 29 is a bit weird. Like, I would usually set that to 28, but it doesn't really matter that much. And the WRD DG can often go lower than just 24, but yeah, all looks good. Like, there's not really anything I would massively change. And round trip latencies, 71, apparently 69. I don't know what these are supposed to be off the top of my head for this kind of setup. And then we have cold boot instability in winter when room temp is sub 15C. Yeah, point a hairdryer at the memory sticks. This is a real problem with BDI memory sticks. A lot of BDI has, like, a very specific best operating temperature, and that best operating temperature is like 20 degrees Celsius, or like 22 or something. Like it's between usually somewhere between like 20 and 30 degrees Celsius is like optimal operating temperature. And anything below that, like, and this varies by kit and to some extent motherboard, because some motherboards I think have like some training optimizations to get around this. But basically, BDI can actually get too cold to post, which is what this is. And there's really no fix for that, other than like buying a bunch of other memory, like trying to find memory sticks that don't do that, or heating up, like preheating the memory before booting the system. You're not the first person I've heard of to run into this, where like, yeah, my room gets cold and then my BDI memory sticks refuse to initialize. That's actually pretty typical behavior for Samsung BDI, is some sticks, like they go below 20 and they just stop working. That's why you don't really see like towards the end of the DDR4, towards the end of DDR4, like people did start figuring out how to run BDI on liquid nitrogen, but for the longest time, like there's like system pictures of people running BDI memory sticks with like heating strips, like tape with just like a resistive element built into it, and they'd stick that onto the memory sticks. So when they're running the liquid nitrogen, the memory sticks don't get too cold and stop working. So you'd like hold the temp memory at like 20 degrees and the CPU at like minus whatever, right? And yeah, BDI things. Yeah, after warm up it works. Yeah, that's just BDI things. Like either bin a bunch of memory kits until you find some that work at 15C, or just hit it with a hairdryer every time you want to boot, because those are kind of your only options as far as I know. Or don't turn off the system. Anyway, next timings. I've got a 5900X with 64 gigs of memory running XMP. Ugh. Ugh. So usually I'm pretty loosey-goosey about TRFC, but this right here is, ugh. This is bad. What is this? Hynix of some kind? It's a team group kit, so it's probably some kind of Hynix memory. Yeah, this is a problem. Unfortunately, the ICs that I suspect this is don't usually do very good TRFC even when you do tune it, but I think you should be able to at least get it to like mid 700s instead of 900, which will help. And then like TRDs, like I'm pretty sure, yeah, like this is bad. Like TRDs and TFAW here, this, no. Like, I'm not sure if this will do 4416, but like I'd try like 4816 or something, or like 4616. And like I'd start by lowering TFAW to 16 and checking that it doesn't like immediately ruin stability, and then drop TRDS to 4. And then the SCL timings, these should be able to do 4.4. If this is the IC that I suspect this is, you're probably not going to be able to go over 3666 on the memory. Is there any extra context for this other than, oh yeah, there's just default XMP. Yeah, so like it might do 3666. You can probably tighten the primaries a bit. TCL, I'm not sure. It might do 16 at 3600. Because the thing is, like, this spec of, like, 3600, 1822, 22 is actually designed for CDI, as far as I can tell. So you get a lot of memory chips that can do better timings than this in the, like, CDI spec, and then it's like, oh, the primaries are unnecessarily loose. Funnily enough, yeah, and then for your dual rank timings, like 4, 6 on those. I tried that. TWR can definitely go lower as well. WTRs should also go lower. So yeah, they're like you just kind of need to adjust everything. I'd probably yeah, though actually maybe I would first start with checking what kind of speeds you can do. Just like bump the memory voltage to maybe like 1.4 and then see if like 37.3 3733 boots. It might, like, depending on which Hynix this is, it might, and if it's, like, or it won't. Those are kind of the two options as far as I know. It'll either work or it won't, and if it doesn't, then I'd try 3666, and then if 3666 doesn't work, then yeah, I just drop back down to 3600 and start like fine-tuning the timings. And actually, you wouldn't even, like, if it doesn't work at 3666, then I wouldn't even bother raising the voltage, because I don't think that's going to help these at all. But yeah, you can definitely shave off a few, like 100, 200, maybe even 300 clock cycles of TRFC. SCLs, I would assume, should just work at 4.4. I can't see, like, yeah, like, I would go straight to 4.4 for the SCLs, try that. And then TRDs would be the next thing I'd pay a lot of attention to. TWR, like, you can usually lower a lot, but it doesn't tend to affect performance that much. But, like, this is kind of, yeah, awful. So, anyway. Somebody failed to, like... You need to post the freaking link. WikiLeaks. You need to post the link. Like, you just posted Imgur. There's no link. Okay, so we've gone through the default XMP. Hopefully that, like, is helpful with the tuning my suggestions, but the thing is, I've not... Like, I do actually have a team group kit of, I think, this Hynix memory chip. But I've not, like, stress tested it extensively. I just remember it being kind of terrible. In terms of especially frequency, like, it just didn't clock and TRFC didn't get lower. Anyway, next timings. Also, I'm probably going to be closing submissions soon because we're at an hour and like 17 minutes. Oh, we got a 3400G. Which is Ryzen 2000. Yeah, that's Zen Plus. Yeah. And we have some... What is this? Ooh. We have a label. I think this... Wait. Is that... I think this is the assembly year. 2303. C16FN. Wait, how much? 16 gigs. Are these X16? Oh yeah, these are SODIMMs. So this is going to be X16, isn't it? So this is awful. Like, the memory is. We're not even talking about the timings here. But the timings are actually, yeah, the timings actually look good, like, fine-tuned. It doesn't, the clock isn't super high, but that's not related to the X16. I think that's, like, if I remember how to read this correctly, this is C-die Micron, right? Yeah, because this is crucial part number. So this is Micron C-die, 16 gigabit in X16. So you have 4 memory chips on each memory stick. Each memory, there's 2 wait, it says dual rank. I'm pretty sure that's bugged out. Because it is a SODIMM, so that would... Wait, no, it's a 16 gig SODIMM. What? What is this? Man, I'd love to see what these sticks look like. So it might just be single rank? I am so confused. I wish I was better at reading crucial part numbers. Probably tell me more. Anyway, well, it is pretty well stress tested, and in terms of the settings, DDR4 3333, which, yeah, as far as I know, CDI doesn't clock super well. And we're also on a Ryzen 3400G, so like that memory controller also isn't exactly known for doing high clocks, so that's not surprising. And then 16, 20, 20, yeah, well, there's not really anything you can do about that as far as I know. TRAS at 21, TRC at 56. Oh, so you're doing the thing where you just ignore TRAS. Cool. TRD SNL at 4s, TFall 16, so that's good. WTRs are good at 4.8. TWR at 10, that's also good. TRFC at 520, which that's just going to be limited by the memory sticks. And read-to-read, like the SCLs are at 2.2, which is, yeah, that's not going to get better than that. And TCWL 12, which is that's like surprisingly low, considering that you're at CL16. And then RTP 8, RDWR 12, WRD at 0, which is interesting. Yeah, I think that's like the first time I've seen that. And then your dual rank timings are also tweaked, though I am not, like, I can't, is it actually dual rank? Is this like X16 but dual rank, which would be like so weird? Well, maybe not that weird for SODIMMs. How would that even work? You'd have like 4. I am really struggling with. You'd have like 4 memory chips on each side of the stick. Right, that would make sense. So actually, if this is dual rank, the performance might not be that bad. It's like because the thing with the X, I'm still assuming these are X16 memory chips. But basically, the problem with X16 memory chips is that they have less bank groups, so they're basically like half a rank. So you need you basically need 2 ranks of X16 to match a regular single rank regular X8 single rank stick, in terms of performance. So this might not be this is not great. And like the memory here is not great. The timings are actually good. Like you've done a good job of like minimizing all of them. But yeah, the memory chips don't seem to be very good. So that's unfortunate. Okay, well, why doesn't this work? Okay, there we go. Got that. Up next, we have a Ryzen 7600 with a interesting configuration of Y-Cruncher. Not that I don't think it'll cause any issues. Why did I not copy the damn link? So yeah, Ryzen 7600 on a B650 Aorus Elite AX, running M-Die, I'm assuming. Actually, this is a 6432 kit, so probably A-Die. Also, man, that is a good memory controller. That is a good memory controller. 1.2 volts SoC for 6400. This can probably boot 6600. This can maybe even run 6600. What is with these SCLs? Man, I didn't want to zoom in directly on the timings. Why? Like, let me scroll through this, okay? So, okay, you didn't... What is this? It's like you watched half my video and, like, did... while drunk or something. 'Cause, like... Seriously, what is this? Like, like this is a 3239 G-Skill kit, so normally the cast latency would be 32. So let's go through this thought process, right? Cast latency, this is everybody's favorite memory timing, which is why it's at 30, right? Because we got to get that low cast latency. It has latency in the name, so we have to lower it. TRAS gets set to 50, which is like a pretty random number. TRC's at 80, which is like, yeah, even more random after you consider what the TRP is at, right? Like if this was at 89, it's like, okay, but it's at like 80? Okay. Then TRD SNL is literally on auto, but Tfall got set to 20, which, to be fair, like, yes, I do give Tfall a lot of attention. Actually, that's not true. I usually say that Tfall doesn't matter as soon as you set it below your TRDs. Or equal to your TRDs times 4. So, like, I don't know what's going on over there. The WTRs are auto. TWR is at 60? What? Why? Like, it's 12 ticks away from the register limit. Why didn't you just, like, because on default, like, default TWR is like 100 something. So, like, you definitely adjusted this. But why 60? It's just like, oh, I'll just take the XMP timing and divide it by 2 or something. But, like, he didn't do that for any of the others, so, like, yeah, okay. So, anyway, that should probably be 48. TRFC 500, okay, fair enough. Like, I don't really see a problem with that. Refresh interval at 50,000, so I'm assuming you watched my, like, lazy Ryzen timings video. And then just didn't follow most of, like, the SCLs are so bad. Like, they're literally auto. Like, this should be 4-4. Or, like it should be 4-4. And then read to write and write to read is also at, like, 16 and 8. Well, 21 and 8, when it should be, like, 16 and 4 or 2 or even 1. It can sometimes work. Yeah, so this is bad. And we've run like 30 minutes of Y-Cruncher. And for some reason you actually set it to like do a loop every 30 minutes, which is like, it doesn't I don't think that actually affects anything, but like why wouldn't you just run the default 2-minute loop time? But yeah, no, these timings are not good. Like, they're just not good, because this is like XMP, but somebody like changed like 4 of the timings. Okay, no, like wait, let's go. So let's count how many timings were adjusted. Okay, TCL, TRAS, TRC, TFall, TWR, TRFC. I'm not gonna count TRFC2 and same bank because they don't matter. And that's it. Oh, TREF5. So you adjusted 7 timings. And you set one of them so low that it actually just doesn't do anything, that being the TFall. This is, yeah, no, this is bad. This is just bad. Like, look at some of the other, like, go back through the, like, after this live stream, maybe go through the live stream and look at some of the other timings other people are running. Because we've had plenty of good timings show up today, but this is not it. So I don't, like, this isn't even generic. This is just bad. Because apparently this, yeah, like, in his super chat, he's like, generic tune, and it's like, you don't, like, you didn't even copy good timings. Like, I don't know how this is generic. Anyway, next timings. WikiLeaks got through. Or wait, what? Don't super chat again. Okay, got it to work. Cool. Anyway, so we have a 3800 XT. That is a weird CPU to see in the wild. Like that's not a popular CPU. On an X370 Taichi running 3600 on 32 gigs. Is this? Yeah, this is 4x8. Cool. I mean, I think you probably wish it was running higher speeds, but I don't really know how well that board handles higher speeds than that. So yeah, 3600, 14, 14, 14. So pretty standard stuff for the primaries at 1.5 volts. That's on the higher end for flat 14s, but then, yeah, it makes sense. It's still on the higher end. Like some kits could do these kinds of timings at like 1.45, but then again, some kits can't. So it might be one of those, especially like I'm assuming this isn't like a matched set of memory sticks. But yeah, so 14, 14, 14, 28, TRC at 40. That's getting auto-corrected to 42 because your TRP's at 14. So like you'd like for 40, you'd want your TRAS at 16. I mean 26. Yeah. Anyway, TRDS at 4, TRDL at 4. Wait, is it 26 plus 14? Yeah, that would be for 40. TRDS and T4 are good. WTRs are on the looser end, but fine. TWR 12, cool. Usually that can do 10, but 12 isn't really going to be a massive, like, yeah, massively slower. Actually, the WTRs, you could probably run 4.8 or like 3, or even 3.7. Might be worth trying if you don't feel like trying to push the frequency higher. TRFC 280, good. SCL's at 4.4, good. TCWL 14, that could probably be 12. RTP at 8, cool. TRDWR 8 and WRD 3. And your different rank timings and different rank timings need to be adjusted. This should be 4466. Otherwise, you're going to be like, yeah, like this is costing you a bit of memory bandwidth, basically. Because you are on a dual rank setup, so I'd really, 4466 on those. That shouldn't cause any stability issues. That's like the biggest change I would make to this, I think. Like, yeah, some of the other timings could be a bit tighter, but I think the biggest performance impact would be like setting the different rank and different DIMM timings to 44 and 66 instead of 5577. And yeah, I don't see anything else to really complain about. Like, I don't know if, like, I'm going to assume that the memory speed is just limited by the motherboard because this is a, like, X370 board, and I had an X370 Taichi. Even compared to other X370 boards, it's not the best memory overclocker. So... Anyway, did I miss any? No. This should be the last super chat, and then I'll do a few of the, like, free, like, I'll pick a few at random, because, yeah, I've completely lost track of the non-super chat ones, and then, wait, what? How am I not? Okay, so we've got another 7950X3D on a X670 Extreme. I do not approve of your choice of motherboard. Why would you spend that much money on a motherboard? What is wrong with you? You do realize that it's going to be completely obsoleted by, like... it was obsoleted when it launched by the Gene. Like, if the Extreme was a 1 DIMM per channel, I could kind of understand, especially since you're not even running, like, a huge amount of memory. I really hope that you needed, like, 10 gig LAN and dual 4090 support or something, because otherwise this board just makes zero sense. Because technically, it does, like, if you have, like, a very long and kind of convoluted requirement in terms of motherboard functionality, the Extreme ticks a lot of that list. It's just that if you just gave up, like, let's say you just gave up the postcode, you could just go get the ProArt board. If you give up the 10 gig LAN, you could get a Hero. If you actually care about memory performance, you'd get a Gene. If you, like, dumb board. Anyway, we've got some 16 gig. Also, like, even and the worst part of the big overpriced 4-DIMM motherboards, right, is you wouldn't stick 4 memory sticks in there anyway, because then the memory is going to run like garbage. That's the best part. Is like, yeah, I'm going to spend all this money on a motherboard with a memory topology that is, like, physically flawed. Because it supports way too many memory sticks. Anyway, so what are we looking at? 6400, 1.26, and synced UCLK. So yeah, that's a strong memory controller. Not as strong as that. Like earlier in the stream, somebody had like a chip that was doing 6400 at 1.2. Admittedly, the timings were kind of loose, but even then, like 6400 at 1.2, if I remember correctly, the timings were kind of loose. But yeah, 6400 at 1.2 is insane. Like a lot of CPUs, you won't even get into Windows at 6400 and 1.2 SoC, regardless of what you do to the timings. Anyway, so this is not that insanely strong, but still like a good chip at 1.26. Because a lot of the time you'll need like full 1.3 volts to get 6400 to work at all. Anyway, so 6400, 32, 38, 1.4. Yeah, okay, that makes sense. 38, 38, 36. So slightly tuned the TRP. 34 might work, but then again, it might not. So I wouldn't stress about it. TRAS at 28, right? Because Asus lets you set it lower than, say, Gigabyte does. TRC at 64. Yeah, that's good. TRD's good. WTR's good. TWR 48, cool. TRFC. Is this not? This is 8i. You could run the TRFC lower if you wanted to. SC, what? I guess that might be because you're at 6400 that it doesn't go lower. And I have heard of some memory kits that like don't do low read to read SCL. Or like they need a ton of voltage. Or wait, no, I think it was like it rolls over with voltage or something. I'm going to assume that this is actually like necessary and that you tried 4, because this isn't auto. Like this isn't like this doesn't look to me like you just forgot to adjust the timings. It's like you probably tried 4 and it didn't work. In which case, okay, fair enough. That's that, I guess. If it doesn't work at 4, then yeah, like running it at 6. Though I wonder if 5 would be a viable option, assuming you didn't test 5. Because yeah, with AMD, the time, like the secondary, like the timings don't have to be even. Intel with DDR5, the tertiary timings, I'm pretty certain the timings all have to be even numbers. But AMD's 1-to-1 mode, I'm pretty sure odd numbers actually work just fine, like work correctly. Anyway, RTP at 12, TRD-WR at 16, cool, WRD at 2. Cool. And then this is a single rank setup, so the dual rank timings don't matter. Oh, and you even have power down disabled. Yeah, so this looks good. I just don't approve of that choice of motherboard. Is there anything else? I mean, yeah, voltage is 1.3, 1.3. Those are sensible. CLD over VDDP, a bit on the high side, but for 6400, that may very well be necessary, so... Like, I wouldn't bother to adjust it down. Okay, and I'm actually going through these faster than I thought I would, so... Or there's, like, less of them than the first time I did this. I mean, I am also doing this at, like, 1 a.m. instead of... Last time it was at, like, a reasonable hour, so... Anyway, we have another super chat submission, so that's going first. You have a 5800X3D on an X570 Tough Gaming Plus motherboard, so I've managed to read that in like the worst possible order, Asus board. 16 gig DIMMs, 16 gig DIMMs, running 3800. Is this B-die? Oh yeah, it is B-die. That TRCD, that's a straight giveaway. There's no voltage readout, which is like memory voltage readout, which is a bit unfortunate. Not the end of the world. 16, I'm assuming this is running pretty reasonable voltages, so like 1.45 probably, maybe even less than that. So yeah, 16, 8, 15, 15, 30, 45, good primaries. I have absolutely nothing to complain about. Like, you could maybe try pushing the TRAS and TRC lower if you wanted to, but I wouldn't, you know, really. Well, actually, that would usually require more voltage. So yeah, if you're trying to run this at like sensible voltages or something, then I would not bother with that. TRRDs 4416, good. WTR at 410. Yeah, like there might be like a couple ticks left. Like WTRS might be able to do 3 maybe, WTRL 7, but I wouldn't, you know, like stress out about that. TWR 12, cool. TRFC 288, cool. FCL's at 4.4, good. Might be worth trying 2.2 if you haven't tried that, because a lot of the time that does work. TCWL 16, cool. Like, I'd be surprised if it couldn't go lower, but it also won't really make that much of a difference. RTP at 6, that's basically as low as it goes. I think the register limit is literally 5. Like, you can't set it below 5 because the CPU is like doesn't understand the concept of an RTP of less than 5. TRDWR at 8, WRD at 2, good. And you have your dual rank timing set correctly. Yay! So yeah, this is just a nice setup. You're not even running like crazy high SoC voltage or anything. Like, that's actually a very low SoC voltage. Then again, I usually don't bother minimizing it when it comes to SoC voltage. Like, I just kind of, like, for Ryzen 5000, I usually just go straight to 1.5 and then do all my tuning from there. I mean 1.15, not 1.5. 1.5 would be a big problem, potentially. Do not set your SoC voltage to 1.5. That's a terrible idea. But 1.15 is usually what I go with. That's also a lot of motherboards will default to that. And then just work from there. But yeah, so 1.08, that's actually kind of optimal. Like, that I'm not sure like that's necessarily fine-tuned, but that's like a very sensible SoC voltage. And then CLDO, VDDP, and VDDG, CCD, VDG, DG, IO die all look good. Yeah, your SoC voltage is actually high enough for your IO die voltage. Oh, that's something I forgot to mention in one of the earlier screenshots. I remember there was one where the SoC voltage was like 1.21 and the VDDG IO die was like 1.15. So it's like, because the regulator that generates VDDG IOD is connected to the SoC, and it can't it can't lower the VDDG voltage by more than 50 millivolts from SoC. I mean, less than 50 millivolts from SoC. So if you want to run like 1.1 IO die and 1.1 SoC, you can't, because the regulator that generates IO die voltage, you always lose at least like 40, 50 millivolts. It can't like just pass SoC voltage straight to the VDDG IO die rail. But yeah, this looks good. And then like FCLK, everything's at 1900 synchronized. So yeah, just a good setup for a 5800X 3D. Cool. Next, how do I send my timings? Imgur link. I think you might even be able to paste the entire link straight into chat. Okay, so I've obviously lost track of the non-super chat submissions, so I'm just going to pick something at random. Like, I'm going to scroll up. Am I going to scroll up? Actually, no, that's dumb, because like there's chances are whoever posted ages ago is already gone. So I'll just take the most recent one. There, we've got a Ryzen 7000 coming in again. Man, I'm surprised that there's not more Intel submissions. Like, I know I said that I'm not, like, I'm not going to make any more Intel memory overclocking content, but that doesn't mean I won't judge your memory overclocks on Intel CPUs. Anyway, so we've got a 7600X running, wait, did somebody copy my daily? No, it's not exactly a copy of my daily settings. It is very close, though. Oh, I was hoping it would get bigger. It didn't. Actually, wait, no, I still want to do that because zoom, like, if I zoom in on the Imgur website, it's going to be awful because the UI, like, gets all in the way. So yeah, 7600X on a B650M Pro RS ASRock board, and we're looking at 2200 FCLK, which makes sense because that's a very sensible SoC voltage right there, just under 1.2 volts. Some really good CPUs can run 6000 at like 1.0 something volts for 6000. Unfortunately, I don't have any CPUs that do that. But yeah, I have heard of chips. Those are probably the chips that can do like 6600 at 1.3. But anyway, so 6000 daily 140 cycles of PCB destroys 16. Okay, so just ran every test there is. Man, that is a lot of testing for a very tame 6000 setup. And this is 16 gigabit Hynix M die. And yeah, we're looking at 30, 36, 36, 36, 34. What is up with that TRC? I mean, it doesn't matter, but like that doesn't make sense to me to set the TRC that low. And with DDR5, if you set, like with Ryzen, if you set the TRC super low, it can actually sometimes cause issues. Even when you like set it like what would on like theoretically impossibly low TRC settings, can sometimes cause the system to like not post or be very unstable. So yeah, I'm very surprised about that being there. Anyway, then we have TRDs, good, 4416. Oh, right, because ASRock doesn't enforce the TFAW timing limit, so that's probably getting rounded up to 20, but it's fine. WTR is really minimized at 214. Like, yeah, I don't usually bother to, like, tune these to their absolute limit, and this is basically that. This is their limit as far as I know. TWR 48, so that's minimized TRFC at 494. I'm surprised that all your other timings are so loose, and then your TRFC is like I think it could probably be a little bit lower. Not that it would make much of a difference, but like also like why like this is basically 500, so I'm like kind of confused as to like that's not 500, but at the same time it's just kind of a random number to type in, but cool. SCL's at 4.2, cool. TCWL at whatever, like, yeah, you don't get to change that one. RTP at 12, good. TRDWR at 14, that's actually, yeah, that's tighter than usually what I would go with, but can work. And then all of the other timings are at 1. And this is a single rank setup, so yeah, that's not going to cause any issues. So, yeah, just a solid daily setup. Yeah, with 1.42 volts on the memory, which, yeah, for... Actually, I think the cache latency probably doesn't require quite that much, but the TRCD could. Or it can. Like, the TCL could also be part of the requirements there for the 1.42 volts. And then IO, VDDQ, and VDDIO, 1.35. Pretty standard stuff. Right here. That is a lot of stress testing. that is an insane amount of stress testing. And especially for such a like tame setup. Tried to run 6200, but no matter what I did, one of all tests failed. That sounds a lot like that sounds a bit like my 7800X 3D. Unless like you didn't just try to smash the SoC voltage to 1.3. Primaries don't do 2 ticks lower. Didn't bother turning off GDM. Yeah, I don't either. TRC equals TRS is real. What do you mean by is real? Like, that boosts performance? Because, like, I've struggled to measure TRAS, like TRC and TRAS, like, actually TRAS especially affecting performance at all has been, like, a thing that it's like, yeah, that is a massive pain to test. Could go down to 1.15, but it was sometimes unstable reboot to reboot. Yeah, okay, this CPU also just sucks. That is so much SoC voltage for 6000. That sounds so much like my 7800X 3D. Yeah. I also can't run 6200 on my 7800X 3D, like, at all. It just doesn't work. I'm not sure if it's, like, specifically one like, TestMem5 that doesn't work, but it just, I think mine errors out in, like, Karhu or something. But yeah, like, good job on the timings. And also on the stress testing. That is a lot of stress testing. And like, a good variety of it as well. I get a bit lazy with the whole, like, oh, I'll just, like, run Karhu forever and you know, Y Cruncher and then Karhu forever. When I remember to check up on it, it'll be fine. We got another super chat in, and I think we're 10 minutes. I mean, I don't feel like stopping quite yet. I don't really want to do like a 3-hour stream though. Okay, so next up we have a 17900X on an X670E-E Strix board, running 6200 with 2133 FCLK. That is an interesting choice because 2066 could potentially, depending on the workload, could actually be faster than 2133. Reasonable SoC voltage for 6200, so one of the better CPUs. I mean, we did also see a bunch of 6400 capable chips earlier, but yeah, like there was also that 7600X that like rivals my 7800X 3D in terms of capabilities to run 6200. So we've also seen some terrible Ryzen CPUs today. Anyway, yeah, so 6200, what is this? 6432. I'm going to assume this is probably a die. And then we've got 32, 38, 38, 38, 36, 74. Cool. TRDs. TRDs 4820. Cool. This kind of looks like basically my lazy Hynix timings. WTRs at 416. Very, yeah. Oh, yeah, 16.4. So one of the reasons I tend to set these to like 416 and 16.4 is that it just makes it easier to remember. Because technically WTRL will usually go lower than RDWR. But man, it's so much more convenient when you can just remember, oh yeah, these two timings are the same thing. And it's like, and it's not much lower, right? It's like a lot, like technically I think WTRL will typically at like 6200 or 6000, it'll typically do like 14 for a lot of Hynix sticks, which is like, whereas RDWR, on a lot of sticks, you can't lower it below 16. Like it will just not work. And it's like, yeah, I'll just use 16 for both. You know, it's kind of this, like performance wise, basically the same. That's like the thing is, like 2 ticks of basically any one timing is just not going to make much of a difference. So not worth stressing out about unless you're benching, right? Like if you're, you know, trying to eke out 1% more performance for that top 10 Y Cruncher run or whatever, or even the top, like depends on how competitive the ranking you're in, but you know, because so like for some CPUs getting top 10 is like, is not that difficult, but then there's other CPUs that are really popular where getting like top 100 is quite a struggle. It's especially true for a lot of like really old DDR3 era stuff. Which funnily enough, a lot of the DDR3 CPUs don't even have that much memory timing adjustment compared to like late DDR3 and like DDR4, DDR5 CPUs. Anyway, TWR minimized, TRFC at 490. That's a sensible value compared to like the 494 that we... Was that the previous one that was 494? Anyway, yeah, 490. So good. SCL's at 4.2, cool. RTP at 12, cool. TRD, yeah, 16. We already went over that 16.4. And refresh interval completely maxed out. Your MEMVDD is bugged out though. So like, what are you running it at? Because these are not crazy timings. Are you at like 1.45 or something? Because, like, like, this doesn't bug out unless you set the memory above, like, the memory voltage above 1.43. But these timings, like, this should work at, like, 1.4, I would think. So I am confused as to why your voltages are bugged out. Like, if this was, like, CL30, actually, even 30 could probably, like, if you got lucky, CL30 might work on 1.4 volts-ish, 1.43. But, like, it's bugging out. So you're going to be on, like, 1.5 VDD, like, 1.45, 1.5, and at that point, I'd expect, I don't know, like, CL28 or something, and lower TRCD. Like, why is it at 38? Like, it would like, with that much voltage, I would assume you'd be able to run at least 37. Not that it would, like, massively change performance, but yeah, like, I'm confused why the voltage seems to be so high when your timings are, like, pretty generic. Oh, Sebi has submitted. Oh, we did already have a 4733 CL14 setup, so, well, I imagine this is still going to be absolutely ridiculous. Unless Sebi posted his daily. I actually wonder what Sebi's daily settings are. Oh. Okay, this is cool. So, yeah. Threadripper. 24 core Threadripper, registered DIMMs, and Threadripper's I/O die is actually just better than the regular Ryzen I/O die. So yeah, like UCLK 3500, you can run DDR5 7000 in 1-to-1 mode. This has been the thing that, like I don't think this is actually going to happen for Ryzen 9000, but it's like, man, wouldn't it be cool if they took whatever they did to the memory controller for Threadripper and just, like, put that on the, like, mainstream CPUs? Because, like, that's the UCLK is, like, the internal clock of the memory controller, right? Like, that's not the ability of the memory controller to, like, ingest data at very high data rates. That's the ability of, like, the memory controller to internally move it into the Infinity fabric, which admittedly here is just a 2166, so that hasn't really changed. But running, like, really high UCLK is really, like, the latency you could achieve. But anyway, so wait, this isn't some, like, super ridiculous LN2 setup. Like, this is like 7032. I mean, that is tight for 7000. That is tight, but that's like this isn't gonna need, like, this should be like 1.5-ish on the memory voltage. The voltages are bugged out, unfortunately. Probably, like, I'm assuming Threadripper is just not super well supported by Zen timings. VDDIO is very high, but I don't know anything about this setup, so yeah. Read to read SCL, does that not go lower, or is that, like, RDIMM things? That I do wonder about. 4040, yeah, that at 7000, you're not really going to be able to run those lower. TRP is ADI. Yeah, this is ADI memory. TRAS, TRC at 40. That is interesting. I'm assuming that this, like, benchmarks faster. Otherwise, this wouldn't be this low. TRDSNL at 4.8, TFall 16, and WTRS. I don't know if there's, like, if the register limit for Threadripper is different from mainstream Ryzen for TFall. WTRS at 4 and 18, which, yeah, for 7000 seemed... I feel like WTRL could probably be a little bit lower. But then again, this is registered memory, so I don't know, that might change things there. TRFC at 480. Kind of on the high side for ADI, I think, but, like, at 7000, but also 65,000 refresh interval, so it's not like it really matters that much. Wait, how many channels is this? Single rank. Alright, I can't do big math in my head. Like, multiplying things by 16 is not something I'm good at. This is 8 sticks, though. Wait, does this... So this is octa channel, right? Wait, WRX90E Sage. 8 channel? Oh yeah, it's 8 channel. Okay, that makes sense. That makes sense. Yeah, so the dual rank timings are not relevant to this setup. Ooh, and we have a Y cruncher. Unfortunately, I don't have context for this. Let's try get some context. Okay, I am actually gonna. We're over. Yeah, we're basically at 2 hours, so I am going to be closing submissions going forward. Anybody who's already posted, I'm gonna do the 2 super chats, and then if I feel like it, I'll take 1 free one, and then that'll be the end. No, hardware bot isn't down. It's just my link to it is weird. So what is this? This is a 7965. And White Cruncher 25. Wait, that's the long one. Well, yeah, wait, this is literally I don't know what this can 256. Yeah, that sounds like 4 minutes and 16 seconds. Yeah. Literally the world record in White Cruncher Pi 25 billion. Also the CPU's at 5.4 gigahertz. Wait, is this just water cooling? Oh, it's on a chiller. Yeah, that makes sense. I'm assuming the power draw reading is bugged out because 512 looks like like some register got maxed out. Yep. Also, like 25 White Cruncher 25 billion, like that like it takes 4 minutes. So this is like, as far as like benchmarks that you could be pushing, this one kind of has some of the highest like stability requirements. Obviously not the same as running a stress test, but yeah, this is far like you have the overclocks where it's like I can barely run Pi Prime or Geekbench, and Geekbench is heavier than Pi Prime. And then you have like I can run Y Cruncher, like a 4-minute Y Cruncher run, and it doesn't crash. So yeah, this is very fast, literally the fastest, and also quite stable because like it finished Y Cruncher, which is quite the achievement. And that is at 1.3 SoC. So yeah, it would be cool if we had this memory controller on mainstream Ryzen. Though the funny thing is though, I say that I don't know if like clock for clock the Threadripper memory controller might not have higher latency. Because like just because it clocks higher doesn't necessarily mean it's actually faster. But it probably is. Apparently reading is hard. Because I'm pretty sure you just posted that. Or wait, was that already there? No, I think that was already there. Oh, the chat, I think, bumped it up. Okay, no, you're fine. Like, you're still in. Nope, that's not how links work. Oh, a Ryzen 7 7700. Swapped 7600X for a 7700. And we got a Meg series motherboard. Ace. Okay, what is up with these insanely high-end, expensive motherboards? And like budget CPU, like borderline budget CPUs? I do not understand. You do realize your motherboard does not make your your $600 motherboard does not make your $300 CPU faster by much, or really at all. But anyway, ooh, we got another 6400, but this one requires a lot of SoC voltage, yeah, which is pretty typical, and it's 96 gigs. Damn. I'm gonna assume the SCLs are actually just like limited here, like they don't go lower because that is not like that's not auto. Wait, is this a follow-up to an earlier submission? Because this looks because you roasted it last time. What? But I roasted a 7600X on a carbon board. I don't remember roasting a 7600. What other 7600X did I roast? Also, like if you're happy with your system, you don't have to spend money on a better CPU just because some random guy on YouTube said your choice of CPU is weird. You know, like just saying. No, it wasn't Ace. Was it an Ace? Yours was an Ace, but there was like somebody earlier today that had like a carbon. I swear there was a carbon. Also, I don't see your name anywhere earlier in chat. Though the chat could have also just like decided to, you know, not be cooperative again. Anyway, so yeah, 6400, 3038, 1.43 volts across the board. So voltages make sense. 8832, 618, 535. What? Okay, this is very different. Wait, isn't there like a bunch of extra detail? This system also looks different. Wait, no, actually, I'm confused. Doesn't matter. I am just going to pretend like this isn't related to anything else. Fixed my refresh interval. Wait, were you the guy who was running like 32,000 refresh interval or something? If memory restore power down on, I like my fast boot. Well, good for you, because for me, memory restore seems to not work even if I leave power down on. I had to turn it off on my daily system and I still have power down. Like I have MCR off and power down on because MCR seemingly caused some issues. And I've not had issues since I turned off MCR, so hopefully that like we'll see. Because the thing is like the MCR issues like show up at random and after like random amounts of time, right? Which makes it the worst. Anyway, yeah, so the primaries look fine. Yeah, 30, 38, and like it's at 6400, so that's actually quite nice. And then 8832, cool. 618, cool. SC, I already commented on the SCLs. Read to write, WRD. That WRD is weirdly high, but probably doesn't matter very much. Also, your RTP could almost certainly be lower. Not that I think it'll drastically change performance or anything, but it could be lower. And yeah, so like the timings look fine. But if you bought a 7700 just because I said your choice of 7600X is weird, your decision-making capabilities are like, I mean, your decision-making, like, and you put a 7600X into an Ace board, so that's already like weird decision-making right there. But then buying a different CPU just because some guy on YouTube said that your first CPU is like a weird fit for your motherboard is worse, I think. Like, and you have a 4090. Like, I do not understand. Are you waiting for, like, is this like a waiting for Ryzen 9000? Like, was this a waiting for Ryzen 9000 system? Or like, do you just let other people choose your parts for you? Like, did you just go on, like, did you go to, like, Reddit or something and go, like, best GPU, and everyone's, like, 4090, so you have a 4090. Then it's, like, best motherboard, and it's, like, it ends up with an Ace, which I don't know how that ended up on any best motherboard list, but it does have a really cool feature set, but anyway, like, I don't know that I would necessarily consider it the best option, unless you, like, need 10 gig LAN and a bunch of PCIe lanes, and, like, the PCIe layout on this board is really cool, in my opinion, and it has 10 gig LAN, and I think it even has, like, the Thunderbolt chip, but either way, and then, like, you go and ask what is the most cost-effective gaming CPU, and you end up with a 7600X? What? Also, said budget CPU is apparently, like, on a custom loop. Talk about priorities, man. And it has 96 gigs of memory. This is like some... Like... you know, like it's bad when you see an i9 paired with like a GTX 460, like a RTX 4060, right? That's bad. That's also bad priorities. But this is like the inverse of that. Expensive RAM, expensive board, expensive GPU, and then the CPU is like, what? I am so confused. Expensive cooling. These are Fantex T30s. These are like $30 fans. And he's not even using them to cool the GPU. He's just cooling his... Wait. And he's got Noctuas. He has like an entire CPU worth of fans in his system. And he's on a Ryzen 7700. And there's a little smiley... I do not understand. Like, I guess if you play, like, AAA games that are massively, like, you know, all the ray tracing and, like, 4090 struggling to get 60 FPS, it doesn't really matter if your CPU is a 7600X or a 7700, but, like, I am so confused. So very confused. Anyway, there was one more super chat that I need to go through. And then I think I'll take some random free ones and that'll be it. Actually, not random, but like we'll see. We'll see. Apparently, I am really bad at copy pasting. This has been happening throughout the entire stream where I go to paste a link and it doesn't paste. Or it doesn't give me the option to paste. Another screen too big, letters too small. So we've got a Z790 Nova. How much RAM do you have? What? Isn't this board supposed to be like ASRock's gift to memory overclocking before they released the like ITX Lightning board? Because I remember when this board was like when this board first showed up, I remember seeing a whole bunch of like screenshots of it doing like DDR5 8000 supposedly stable. And then like it's running like you're on a 7000 rated kit and you can't even do XMP? Does ASRock lie? Can't get 6800 or 7000 to boot, stuck at 66 after playing with voltages? This is a catastrophe. I am like 99% certain that's not auto. And this is like... Because, like, here's the thing. Like, I've at this point, I think I've made it very clear that I am, like, I don't know how to overclock Intel memory, like, how to deal with Intel's memory controller. And I don't want to deal with Intel's memory controller, which is why when, like, a bunch of people were like, oh, do you want to test a Nova? Do you want to test a Nova? I was like, no, I actually don't want to test any more Intel motherboards because, like, I like things that work. And Intel memory controllers do not work. But anyway, yeah, this right here. So you send a refresh command every 6,500 cycles, right? And that refresh command is going to take 971 clock cycles. So about 15% of your available memory clock cycles are being spent on refresh. I am pretty sure you wanted to type in 65,000 and just forgot to add the last zero. At least I hope that's what happened. Because if you intentionally put in 6500, that is a catastrophe. And if the board defaulted to 6500, well, I don't believe that the board defaulted to 6500 because while motherboard vendors do stupid things, I don't think they're like that would be worse than J. Actually, well, no, that's too stupid even for motherboard vendors. What do you mean? How did this post? It'll post just fine. Yeah, I'm assuming he forgot to punch in the third 0. Apparently slowing your memory down by 50. Actually, I think auto would have been like 12K or 14K or something. So he's not nerfing the memory that much, but apparently slowing your memory down by like I'm gonna guess it's gonna be like 7 or 8% slower. Evidently doesn't matter that much because he didn't notice. But that is yeah. As for how do you get it to boot at 7,000, I don't know. Like, what voltages are you at? Like the problem is like the voltages what voltages you need like varies by motherboard like very significantly. And I've never used a Nova, and I don't want to use a Nova because like I'd say I value my mental health, but I think we all know that's a lie. But I don't need to it doesn't need to experience more Intel memory overclocking. But yeah, like I don't even know what suggest. Like maybe set your SA. I would try like 1.25 system agent. But I don't know what to do with VDDQ-TX because like some boards hate it when it's too high, some boards hate it when it's too low, some boards hate just freaking running anything that's a stress test. The Intel memory controller is a memory controller for insane people because you can punch in the same settings 3 times and get 3 different stability results. Whereas the AMD memory controller, you set your voltages wrong and it just doesn't post. It's like, oh, your SoC voltage is too low? Yeah, I'm not going to boot. And then on Intel, you also have fun things like some CPUs have a bug where if you set SA too high, they just like randomly lock up, which I've never run into. Actually, no, I ran into that with 12th gen, but I never ran into that with any of the later CPUs I have. But anyway, as for timings, I mean, personally, if you can't get it to boot 7,000, I would just not try to boot 7,000, is my approach. And I would just try to fix the timings. And to that extent, at 6,600, this can be 32, 30. Yeah, I'd go like 32, 39, 39 is 8i, so probably like 36. TRAS at like, should do 30 or 28 even. Actually, if you have a TRCD write, like if you have the option to set TRCD write in the BIOS, I'd set that to like 16 or something. Command rate, I'd leave that at 2. Read to read, this is 8i, right? This is 32, 16. Yeah, this is 8i. So TRRD SG8, TRRD DG4, TRFC 480? No, that's too high for 666. It's 400 something, like 450 or something. Refresh interval 65,000. TWR doesn't exist on Intel. RTP doesn't exist on Intel. Okay, this person actually doesn't know how to read instruction. Wait, that's not a submissions. Check hardware bot submissions for your board. Yeah, because hardware bot is a great place to find stable memory settings. Tfault to 60. Yeah, TFall 16, TCKE 8, cast write latency, I'd probably set like 28, 30, actually probably 30. Yeah, for 32, I'd set it to 30, though a lot of the time it can work at way lower settings than that, but like if you just want it to work, not necessary to push it that low. Read to read, same group, should probably be able to do 12 at 666. Right, 6666. Wait, 6666. Yeah, yeah. At like 6700, we'll just round it up to 6700. So at like 6700, read to read same group should do 12. Different group, you just leave it at 8 because technically you can put in a 7, but that just gets auto corrected to 8. Read to write 20, well, not 24. That should be like 20, 20. This can be 12, 60, 48. Actually, 60, 44 maybe even. Actually, could be really, like, these two could actually go really low because you're at like 6700-ish. I'm not used to it being that low. TWR pre, I'd punch in like 64. And WR PDEN 64 as well. Oh, and RTP 12. But on your, like, depending on how your motherboard implements RTP, you might be setting like RD pre or RTP. I don't know the ASRock BIOS. I've literally never used a LGA 1700 ASRock board. For 6700, I'm pretty sure 12 works for same group. 14 would be like 7,000. $13 and $14 is the same thing. $15 and $16 are also the same thing. Literally all of the tertiary timings only work in steps of 2. And I think it's related to the 2-to-1 mode, because for DDR4, I'm pretty sure the odd timings are real. Who's got the PMIC overvolted? He has the voltages here are just like 1.4. So the PMIC is still in like regular voltage range. But yeah, I guess maybe I might be misremembering the read to read same group to 12 might be too tight, so 10, like 14. But also, since you're on Intel, there's like the, where is it, TRFC per bank? Yeah, you want to set that to be the same as whatever you use for TRFC. Or like slightly lower than whatever you set for TRFC. If you're lazy about it, it can be the same as TRFC, but you do lose a little bit of performance by doing that. It says in hardware info, PMIC overvoltage, yes. ASRock weirdness is going to be my guess then. No, it's not most likely rounded up. Like 15.7 is literally 16.8. Like, I've done a bunch of testing on this. It's literally that. There is no scenario. Like, if you can run 16.8, 15.7 also works. Like HardwareBot is a good place to get a vague idea of like memory timings that are like fast and not like for stability absolutely useless. And also most people don't include their memory timings in their screenshots. So like good luck with that. So yeah, apparently the Nova is really, really good when used by normal people. Like, I knew Intel 4-dimmers are bad, but, like, this is, you know... And that the, like, like, the QVLs for Intel motherboards are made of, like, literally wishful thinking. But, like, I would have thought a DDR5 7000 XMP would at least work. You know? I mean, actually, no, I wouldn't, because as far as I know, a lot of 4-DIMM MSI boards, at least the, like, first wave Z790s, those don't work at, like, 7000 a lot of the time. And the Gigabyte Z790 Elite that I have, like, barely does 7200 after you bend over backwards. And the Z790 Master that I have, like, the old one, same thing. And the Z790 Master X, all it did is change, like, instead of, like, the board like struggles to run 7200 and can't boot like can't boot high speeds at all. The biggest difference between the like original Z790 boards and the refresh Z790 boards is the refresh Z790 boards all boot DDR5 8000 and they still struggle to be stable above 7200. Truly amazing product development. Basically, I'm assuming what they do when tuning Intel memory controllers is just sit there fiddling with the configuration of it until it posts, and then they never bother to check if it runs a stress test. Because, like, that's what it feels like, going through the boards. Like, they all, like, progressively, the speeds that you can boot go up, and the stability doesn't get better. Which is just, like, amazing. The funny thing is, I actually asked about it, and they do at the very least for the QVL run HCI mem test, but I'm assuming they just like bin the CPUs to hell and back for that. $13900 KS on a Z790 Aorus Pro can't do DDR5 6800. Well, yep. Like, I can't say I'm surprised. My first Nova wasn't able to do over 7400, and then the replacement did 7600. Unfortunately, I don't like have like multiple samples of one board, and I'm not looking to like get one do that. But I have heard of that being a thing, that there's like PCB manufacturing tolerance variance that's like significant enough to like massively affect memory speed. Is there a relationship between IMC voltage and VDD VDDQ? Maybe. Like I've just given up on Intel tuning. Like I know when I was getting 7200 to work on the original Z790 Elite, all of the voltages like SA. Actually, no, SA didn't have to be, but the video covers that. But yeah, it was like this really weird thing, like VDD, I think it was, yeah, memory controller, so VDD2, VDDQ, VDDQ-TX, even memory VDD, and I think system agent, they all had to be exactly the same voltage, because if you changed any of them by like 25 millivolts in any direction, it would just not pass Y-Cruncher. And then I'm assuming on some later BIOS versions that behavior is like completely gone and it works at like completely different voltages because, to be fair, you have a similar thing with like early AM5 BIOSes having like especially Gigabyte early AM5 BIOSes behave very differently from the later ones. But they don't do that. They just don't. Okay? Like, your memory VDD voltage doesn't affect your overall memory stability. It just affects what timings you can run. And your VDDQ and VDDIO are, like, the only two voltages that really matter that much for your frequency, which makes sense, because they're used for the actual signaling. And your SoC voltage just sets what kind of FCLK you can run. And then there's the Intel memory controller, where I don't know what anything does, because everything affects everything, and I hate it, and I'm never testing it again. And then you get to find out that the motherboards can't even run the CPU on auto settings correctly. So like when I was so there's like it has been a thing that has crossed my mind at this point where it's like, wait a minute, when I was stress testing the 14900K on auto settings, was it erroring out in like various stress tests maybe because it was undervolted by Asus badly? So that's what, like, it could have been erroring out in because of that, not because of actual memory stability. But at this point, I just don't care. Like, I'm not testing that dumb platform anymore. Not for stability. Not in a million years. So, anyway, I think that'll be it for the stream. Man, I'd actually, you know what? I'd try find maybe a submission that doesn't make me just upset at the state of like motherboard. Like, the thing is, like, I'm like, you might be like, oh, motherboard memory stability has gotten way worse, but it's like, no, I'm pretty sure during the DDR3 era, it was just as bad. It's just that nobody bothered to test, right? Because during the DDR3 era, everybody was like, yeah, all you need is 1600 JDEC. Right, so nobody really cared about like high memory speeds, and then for DDR4, actually DDR4 Intel boards are also sketchy as hell. And Ryzen, well, the thing with Ryzen is you just have 1-to-1 mode, so like the QVLs for a lot of Ryzen motherboards will claim support for like whatever. In practice, a lot of the time that doesn't work on like XMP or XMP settings because Expo wasn't a thing. But like you wouldn't run that because you just use 1-to-1 mode, right? Like like for Ryzen AM4, you just use 1-to-1 mode, and running 3600 to 3800 in 1-to-1 mode just isn't that difficult. But then on the Intel side with like Z390, right? Like Gigabyte, the Z390 Master literally has two drastically different memory topology versions, one which sucks and one which is good. And nowhere in the I don't think there's any indication of that in the QVL. And then for Z390 boards specifically, I know for a fact that like eventually, like a lot of the T topology boards, like the good ones, could run like 4x8 at like 4400. And then a BIOS update came out and that just like stopped working. And if I'm not mistaken, that BIOS update was like a microcode security thing. So it's not really optional, which is just like amazing. Truly. I mean, for like, well, to be fair, I think ASRock doesn't actually have issues with the whole not knowing how to read the CPU power delivery specs, or at least like following the instructions from Intel correctly instead of just not. But yeah, I don't know. I don't have a fix for this kind of thing. Okay, well, let's see if I found settings that don't make me upset. Well, it's a Ryzen setup, so at worst it's going to be boring. Wait, that's not what I wanted to do. There we go. Ooh, a 48 gig setup, and it's running 6400. And kind of generic timings. So we got, yeah, so 6400, 4.4, 1.275 SoC. So pretty solid memory controller on that CPU. RTP12, 30, 38, 38, 30, 68. 6. Oh, right, yeah, the 24 gig, like the 24 gig ICs are worse for RRDs than the 16 gig. TRDL12, T424, that is a really random... oh, no, it's, 6 times 4. Okay, that makes sense, yeah. WTRS 616, TWR minimized, TRFC 512, being fancy with it. The timings that don't do anything are set to 100 because they don't do anything. SCLs are good. And TRDWR 16 and 4. And refresh interval completely maxed out at 1.4 volts. So, yeah, just... and 2133 on the memory. So, like, optimal FCLK for 6400, or, like, best latency FCLK for 6400. I find Buildzoid's RAM reactions very entertaining. Am I weird? Yes, you are. This whole stream, I've been wondering, like, why are people super chatting me to read their timings? Am I giving their timings enough attention? Are they getting value for money? Because, like, you send in a screenshot, and for a lot of these, like, you know, I glance at them, and it's like, oh, yeah, this is really generic. These are some really generic VDI timings. Wait, did I mention that this person should set their dual rank timings? Because I might have forgotten to do that. I'm looking at this. It's like, I can't help it. 32 gigs, 5577. It's not good. Should be 46. I'm pretty sure I mentioned that. I hope I mentioned that. Has a utility to score memory controller quality? Asus has one. I'm not sure how, but I've heard from other people that it's not super reliable. Synchronized BCLK OC. I wonder if that might not just be an issue with the chipset. Or have you had other boards survive that for a long time? Because, like, the whole issue with synchronized BCLK is that, like, it does overclock absolutely everything. Right? So I'm, like, wondering if, like, it, like, makes the chipset, like, corrupt itself, or if it, like, maybe the SMU gets corrupted or something? I don't have enough detail on that kind of thing. Or, like, enough information about that. I have 32 gigs at 5.9. What? 5.9 for what? No, like, if you're on single rank, it doesn't matter. You can technically have 32 gigs in single rank, but if you're on dual rank, then yeah, your SD and DD timings should be 4.4, 6.6. Otherwise, you're, like, it's costing you a bit of performance. Potentially a lot of performance, like, depending on the workload, but... Man, I just remembered that Intel isn't going to be fixing the fact that the socket, like, bends the CPU. Like, they're not, like, the LGA 1700 is the same, like, loading mechanism as LGA 1850. Honestly, I'd consider that quite a value add if some motherboard manufacturer went and, like, designed a well, actually, I think Intel would get upset about that. It's like, nope, you have to use the official socket that bends the CPU. Oh, that I found that really interesting. There was a Gamers Nexus did that interview with Noctua about how, like, the different heatsink bases to deal with the fact that Intel can't design a CPU socket. Or more like refuse. It's not that they can't, because, like, the HEDT Intel sockets are fine. It's just, like, the consumer socket, just, like, why can't you spend, like, a couple cents more on a better piece of steel than this? Like, and yeah. Like, I get that Dell and HP and whatever and Lenovo, like, don't care if the CPU gets bent by how, like, you know, a few fractions of a millimeter after a few years, but, like, I don't want my CPUs to curve that much. Especially when they curve, like, the worst, like, the HEDT sockets bend the CPU, like, inside up, right? So the middle ends up going like upwards, because they apply like a lot of pressure to the out, like on like evenly on the outside edges, so it like bends the CPU. Like you get a bald spot in the middle, whereas LGA 1700 you get a bald spot on the outer edges, right at the top and bottom of the CPU, which is like that's dumb. It's terrible. Like why don't like yeah why well the X299 style socket is obviously more expensive than the LGA 1700 socket, so even though the pin count is kind of similar, which should have probably given them a hint that maybe they need a better mechanism. Anyway, we've got a 5800X3D with a BCLK overclock of all things. Not a very big one. Wait, is this a... Oh, it's a B550 motherboard, so that's why it actually works. Yeah, because like I've heard from people that apparently you can BCLK overclock on X570 boards. Every time I've tried to do it, the board just refuses to post as soon as you go over like 101 BCLK. So I don't know what's up with that, but like it doesn't work for me. Whereas B550 boards, 100 and honestly like 103 even should work. Though it'll start potentially like pushing the memory too high. So yeah, we have 3808. 1512. This is such a random number. That should just be 8. Look, like if you're lowering TRC DWR, just set it to 8. Or like don't touch it. But yeah, 15, 12, 15, 13, 26, 39. So very tight primaries. 4416, good. WTRSL 48, cool. TWR 12, cool. 260 TRFC, cool. SCL's at 4, cool. TCWL, go. Wait, oh, you do have gear down mode disabled. And it's and it's dual rank. Damn. Ooh, Viper Steels. And, oh, and it's like 4x8 Viper Steels. Neat. Anyway, yeah, so 4, 12, 8, 11, 1, 4, 4, 6, 6, good. Yeah, nothing to complain about. Proc ODT at 40, so typical gigabyte stuff. Interesting that your clock drive strength is so high. I've never had a need to do that. Then again, I don't usually bother setting gear down, like trying to disable gear down mode unless I'm benching. So I would assume that this has something to do with disabling gear down mode, and you also tuned your setup times. Yeah. If I'm not mistaken, I've not verified this, but I suspect these are like fractions of a clock cycle delays to adjust the timing when commands get sent, right? Because you kind of need to... Actually, is it commands get sent? Like, it's basically a skew... Like, I think this is actually skewing the... timing of the commands being sent. So it like because of like the whole like the distance that the signal has to travel, the signal like arrives like not necessarily exactly at the same time as the clock or something. And so you kind of like, so the memory controller has the ability to like shift the signal like forward, like I'm not like you have the ability to shift the signal like in time relative to the clock, so that it like so when it's sent from the memory controller, like when it reaches the memory sticks, it's lined up correctly for the memory sticks to register the command. And yeah, as far as like for gear down mode, that can be really, really important to set manually. Yeah, so that's what's going on there. Because basically the whole, like the thing with gear down mode, right, is like if you're running gear down mode with 1T command rate, each command is only 1 clock cycle long. So if the alignment is not good enough, right, because it doesn't have to be perfect. Like the memory, basically what you're fighting against is the memory stick is going to be checking like for commands every clock cycle, right? And the command is held on the bus for 1 clock cycle. So if your command is like a little bit too early or a little bit too late, and the memory stick checks for the command, and like the command is already like falling off, because the command is going to be like like some voltages being like because you have a bunch of signal lines in the command address bus, right? So some lines are going to be pulled high, some lines are going to be pulled low for 1 clock cycle. And so you need all of those to line up with when the memory stick actually goes like, hey, is there a command? And the stick is checking based on the clock signal, right? So if your command is too early or too late, it doesn't register and you get errors. Correct. Like the command doesn't register correctly and you get errors. And if you have 2T command rate, this basically isn't a problem because the command is for like you hold the command for 2 cycles, right? So the alignment is just like not really that important anymore because the command is there for so long. But if you're in 1T and gear down mode has like, I'm not sure how like gear down mode does it, but there's like gear down mode achieves kind of similar things to 2T in terms of like signal, like command integrity, as in like the memory stick isn't going to struggle to pick up the command. But when you don't have gear down mode and you're in 1T, yeah, if the command isn't lined up with the clock well enough, then yeah, the memory stick is going to be very upset. Which is why, like, a lot of the time, if you turn off gear down mode, the system just won't even post, right? It won't be like, oh, it's unstable when you turn off gear down mode with 1T. It's like, it doesn't even post because the memory literally, like, the memory controller tries to talk to the memory at all, and the memory is just like, yeah, I don't understand. And that's when you get the whole, like, it won't even pass memory training. So, yeah, that's what's going on with that. As far as I know. I should probably verify that. Also, this, funnily enough, like, that's actually, like, why 1T command rate can be, like, really weird about, like, being supported, especially on the Intel side. Like, some motherboards will have, like, really good 1T command rate support and some won't. And this is true even in the DDR4 days, where it's like some boards would only support 1T command rate up to, like, 3200, and past that it wouldn't work. Because past that, like, the default tuning of the memory controller from Intel isn't, like, Intel doesn't care about having, like, 1T command rate dialed in. So if the motherboard vendor doesn't go in and fix the timing, yeah, you're screwed. And I think technically in some BIOSes you might have the settings somewhere, like they might be buried somewhere so that you can align the command, like try fix that yourself. But I think Asus is probably the only manufacturer that actually exposes that. And it's probably not labeled very clearly because, you know, Asus' favorite pastime is coming up with unique special names for standardized terminology, which is why they measure termination resistances in clock cycles. Anyway. Okay, now we find... Okay, so I had a few false starts on people not being able to read instructions before, but you actually just don't know how to read instructions. I'm still... You're the last one, and that's the end of the stream. No, we got a Z390 Aorus Master. And it looks like this is probably the good version of the PCB. 390 Aorus Master, been daily stable for 2 years, can run 4266. Temps don't get too high. Yeah, so this is going to be the better version of the PCB. I'm actually going to keep this right down the middle. No more submissions, damn it. This guy gets a pass because his timings are interesting. So we're at 4,000, 16, 16, 16 on the primaries. What voltage is this at? DDR 1.45. Oh, that's really mild. I mean, yeah, for 16, that makes sense. I mean, the TRCD is the one I'm more surprised about working at, like 1.45, but cool. TRS 34, command rate 2T. Yeah, because Gigabyte never... Well, actually, for 4x8, I don't think 1T would be likely to work. TWR12, TRFC 275, TRDs at 4.4, WTRLs at 8 and 4, RTP 8, cool. TFL 16, cool. TCWL 16, this could probably go lower. Default RTLs, I'm not sure if you can fix them on the Z390 boards. I know for Gigabyte, on Z390, You can definitely like tune the IOLs and RTLs to be better than the auto values from the motherboard, but for Z390, I'm not sure if that works. I have a video about that, and that can like lower your memory latency a decent amount. Anyway, also it does affect stability, so like, you know, you're gonna have to re-stress test, so I don't know how much you want to deal with that. TREFI at 32,000. It could be higher, but with your refresh cycle being so low, it doesn't really matter from a performance perspective. TCKE 8, TRDSG at 7, 4, 6, 6. Yeah, so this is, yeah, these are good. And for DDR4, as far as I know, having odd tertiaries does work. It's just like DDR5 where that isn't a thing. Where like 13 becomes 14, 7 becomes 8. But yeah, with DDR4, I really suspect it's down to 2-to-1 mode versus 1-to-1 mode. So actually, maybe on it, like that might be worth testing. Actually, you could test it even with 12th gen, right? Because you can use 2-to-1 mode on 12th gen. I don't know, like not for any real world applications, but like for testing this kind of thing, because I do suspect that that's a 2-to-1 mode limitation where the tertiaries have to be even. Which would make sense if you think about it, because if your like memory controller is running at half the clock cycles of the memory, then like how would it be, you know, like, and the memory controller is issuing commands every clock cycle. Like since every clock cycle of the memory controller is 2 memory clock cycles, logically, you can't align your commands to odd clock cycles on the memory end, right? Because you're at half the clock cycles of the memory. That's also why in 2-to-1 mode, 1T command rate is actually the same as 2T command rate in 1-to-1 mode. So I think AMD has some wacky workaround for that for their Ryzen CPUs. Maybe. Yeah, not sure about that. But like with Intel, that is a thing that like on 11th gen, if you're in 2-to-1 mode, 1T command rate and 2T, like 2T is 4T and 1T is 2T compared to like 1-to-1 mode. Yeah, these look good. And these are good timings. Not anything like super insane. There's a bunch of Z390 motherboards that can like, well, yeah, there's a bunch of Z390 boards that can do settings like this, but solid B-die settings for a daily setup. Yeah. Anyway, that'll be it for the stream. I can boot 2000 on a 5700X3D. With Ryzen 5000, booting 2000 FCLK is a lot less of a problem than actually like being stable at 2000 FCLK. Admittedly, I only have 2 Ryzen 5000s, like 5000 CPUs. Both of them boot 2000 FCLK. Neither of them is stable at 2000 FCLK. They also boot like 2066 FCLK. They're even less stable at that speed. Anyway, yeah, that'll be it for this reacting to timings stream. I will try to do the next one also on like next Sunday and hopefully earlier in the day. Yeah. Not, you know, finishing at 3 a.m. Like, so many hours earlier. Not, yeah. Anyway, oops. That's it. So thank you for watching and goodbye.